from today we are going to start out the Docker tutorial series. So this is our first video in which we basically talk about the introduction to Docker. Okay. So without wasting time, let's start the video actually. So for this tutorial, we are just going to learn about some theory concept, because if you will learn theory then and only then you can implement that practically. Okay. So there is also important to learn about the Docker and all this. Okay, so you should learn the first concept what Docker is. So here you can see I have mentioned some points for you guys, like the basic definition which everyone knows and maybe everyone is aware of it. Like Docker is an app platform for developing, shipping and running application. What does this line or what does this definition actually mean? So it's very simple. You will just think Docker as just one kind of platform, or it is a platform which we use or which software developers use to develop the application, to ship that application to some other place, and then there run that application. So it simply means you will develop one project in the one environment, and then you will just send that project or that environment to the other person or to the other computer, and then there that project will run. Okay, so if you find this definition a little bit difficult or not understandable, so you can also see this second point, like Docker is a platform which packages an application and all its dependencies together in the form of container. So it this line is just similar to the above. It simply means the whatever we will create an application, so in which what will happen, all the dependencies and all the whatever the required software, whatever the required libraries are there, they all will be packed in one single container, and that container will be shipped or will be sent to the other person. Okay, we will see some of the things like how everything goes on and how the actually the Docker works. So we will going to learn with that example. Okay, and next point, if you will see, like developers can create a container image that includes all necessary components of the applications as a core runtime libraries. Just it's same as the above line. Okay, so you can read, and here also the this one is important point, like this image can then be distributed to other developers, test or deployed on different server or cloud platform. Okay, so the basic theory or basic concept about Docker is just like there is one line in the software industry, like this code is working on my machine but it's not working on your machine. Okay, so it's basically just like to solve this problem Docker came. Okay, so let's start with the example. So here I have just you can see the heading, like what problem Docker solves. So to understand this one, I will just create one example for you guys, okay, so that you can understand it easily. Let me just do it. Okay, fine, perfect. So here you will suppose this one is one computer. Okay, I just write here uh, computer one. Okay, and suppose you are building or you are creating some Python based project. Okay, so you are creating project in with name one, project one, and the tool which you are using or the software which you're using is just Python. Okay, suppose here the version of Python is 2.7. Okay, and the scenario is like that. This project is created by your friend. Suppose this project is created by your friend, and your friend sends you this project. Okay, so now in your PC, so this one is computer 2. Okay, so in computer 2, what you do, you again just simply copy this project. So the name will be same, project 1. And suppose here you are using another version of Python, that is Python 3.7, just suppose it. So in this situation, what will happen? The first, like the project which is created is based on the 2.7. So whatever will be the feature of 2.7, that will not be there in 3.7. Some features have changed. Okay. So in this case, your project will not work. So it basically, in this case, we will use the concept or the platform Docker. Okay, I hope you got it. Why this project will not work? This project will not work because the this project is dependent on 2.7 version, but now you are going to run this project on 3.7 version, so it is totally different. Okay, so that's why this project will not work on this machine, that is computer 2. So to solve this problem, Docker came into role. So what Docker can do? So Docker will just simply just create one container uh, in that computer one. So in container, what we can do, we can just install Python 2.7. Okay, and we can create the project one. Okay, and what we will do, we can just send this project. Okay, we can just send this project to this one, to computer 2. We can send it using the container or image. These things we will cover in our further videos about the Docker, like important concept. Okay, so this one is container which is shared with the computer too. So in this, what is happening, you can say this project is created on 2.7 in this container, and here also it will run in on the same version of Python, that is Python 2.7. Okay, so in this way the Docker solves the problem of the statement like this one. Like it's a very famous statement in the software industry, like my code runs on my machine, but it's not running in your machine. Okay, so this is the like most like important or famous statement in the software industry, and this problem is being solved by the Docker nowadays. Okay. Hello guys, now in this video we will talk about the Docker architecture. Okay, so this is also the one very important concept in the Docker series. Okay, so let's start with the video without wasting time. Okay, so for the Docker architecture, in this we have different layers. Okay, but if you will learn about the Docker architecture, so we will also discuss about the virtualization. Like if you're aware of virtualization, then it is very easy for you to understand this. Otherwise, also if you don't know about virtualization concept, then and also it's fine. Okay, so you can get it easily. Okay, so let's start with the layers. Okay, or the architecture. So the very first layer or the very bottom up layer we get is the hardware layer. Okay, so this one is the first is the hardware. Okay, and the next we get is the host OS. Okay, so above our hardware we get the host operating system. So this is the just a basic. Okay, everyone knows about it. So in hardware, what do we usually we get the RAM, we get the hard drives or SSD, and we get the CPU and all those things, motherboard, circuit board, all those things. Okay, we get in hardware. Okay, and above hardware, we mostly install the operating system. Usually, we install the Windows OS. Okay, some people install the Linux or Mac OS. Okay, so some people install these OS as well. Okay, so now we will talk about first we will talk about only these two or normal operating system which we have in our PC. So currently, suppose if I want to install Python, okay, so I can easily install Python in my PC. Suppose I install Python 3.8. So yeah, so I can easily install in my this host OS. Okay, it's fine to install. Suppose if I want to install some other thing. Suppose I want to install Java. Yeah, I can install Java. Suppose it's version 8. Okay, and suppose if I want to install MySQL, I can install it easy. Node.js, all those things we can install it easy. But the problem is there. Suppose if I require the version 2.8, okay, Python 2.8 if I require, okay, Python 2.8 is required for some project, okay, but in my PC there is 3.8. So what I will need to do, I will need to uninstall this version and again install this version. It is not possible to run those versions in a single OS, okay. So this is not a case, we cannot do it like this. So that's why a Docker came up, okay, and with the help of Docker, we what we can do, we can run different versions of a software, okay. We can run different version of softwares, okay, in each container. So how the thing works now? So above the host operating system, we have a Docker engine, okay. So Docker engine is basically used to managing the containers which is created, okay. So here we have the Docker engine, okay. And above this Docker engine, we have the different containers. Suppose this one is container 1, this one is container 1, this one is container 2. Just suppose two containers for now. So this one is container 1 and this one is container 2. In this we have Python 2.7. In this we have Python, just wait a minute. We have Python 3.8. Okay, and this one is computer 1. Okay, so in this way the basic architecture of the Docker works. So Docker engine is basically responsible for, sorry, it is responsible for managing the, I just write it here, for managing the containers. Okay, so all those things is managed by the Docker engine. Okay, I hope you got it how this thing works. Okay, the Docker engine, host OS, and container 1, container 2. So this is the basic architecture of the Docker. Okay. Now if we talk about the virtualization, so in virtualization what happens in the host OS there is the hypervisor, and in the hypervisor what happens, we use different OS. Okay. Like in my PC currently I have VirtualBox. Okay, I use VirtualBox. So if you will see here, in my VirtualBox is one software which I use to run different OS in a single OS. So here you can see I have two OS for now. I have Kali Linux and the Ubuntu. So these are the two OS which is currently present in my Windows machine. Okay. So the how is the architecture if you will see, suppose if I just demonstrate you. So suppose the hardware is my this one normal hardware and I have the Windows OS. So above the Windows OS, what I have one hypervisor. Okay, not in my machine currently. I'm using VirtualBox. Okay, and then what I have two OS. So here, if we see here, I have one is Ubuntu and other is Kali Linux. Okay. So the thing is, and if you will now you will just ask what is the difference between both of them, the Docker architecture and the normal virtualization architecture. So the difference is basically just in virtualization, what happens here, you can see we are installing a new OS. Okay, a new OS, so it will create like it will use more memory. So because of that, our boot time will also reduce. Okay, your PC will become slow. So that's why instead of using virtual machines or the hypervisor or virtualization, we can use the Docker or containers. So we can create different containers, different number of containers on a single machine. Okay, so this is the just the basic difference. Suppose in virtualization you have to run Python, two different version of Python. So you will install Python in this one and Python 2.7 in this and Python 3.7 in this OS. So for those purpose you will need to you are installing the two OS. So that is not a good thing. Okay, and also it will create more load on your host OS. So that's why Docker is mostly preferred instead of virtualization. So I hope you got it, the basic architecture of Docker and the virtual machine, not virtual machine, virtualization. Okay. So here also I have some basic, you can see the image I have, the container architecture and the virtual machine architecture. Okay. So here you can see the infrastructure that is the same as the what I said, this one hardware. Okay. Host OS is there, Docker engine is there, and here app A, app B, app C, app D. So four apps are being run on a single machine. And here you can see the again the hypervisor is there and the guest OS is there, and in guest OS we are running different apps. So this is the basic difference between the Docker and the virtualization architecture. So that's it for today's guys. I hope you liked the video and you got the concept. If any query, then you can ask in the comment section. Thank you for watching. I'll meet you in the next video. Thank you. Hello everyone. Now in this video we will talk about some important concepts like we will talk about in this video on the Docker file, Docker image and Docker container. Okay. So like in this series these are the like very important you can say, or just you can say the foundation of this Docker series. Okay. So let's start with the first one which we have on the screen is the Docker file. So what is a Docker file? So it's a very simple concept. Like Docker file is nothing but just like a text document. Like just we have normal text document. It's also like that text document. Like some commands and some like instructions will be there in that Docker file, which will be used to create Docker images. Okay. So you might feel a little bit of confusing about this, but let me just simplify this for you guys. So you will just think Docker file as just like you can think like it as a recipe. Okay, just suppose it's like a recipe book or something like that, and then you will create some like some good foods. Okay, some tasty foods which you will create. So similarly in Docker file we will have some instructions. Okay, there will be instructions, and we will use those instruction, or we will use this file like Docker file, and we will create images. Okay, Docker images which we will create. So this is the basic funda of this Docker file, and it's a very like simple concept. I think you should not get feel like you didn't get it. Okay, so this is the normal definition of the Docker file. I hope you got it. Now moving forward, if you will talk about the Docker image, so Docker image is nothing but the like the thing which is created from the Docker file. It just we can say it is a Docker image. And also you can see here like it's just a template to create a Docker container. Okay, so whatever we will give the instructions like how you have to create image, what are the functionalities or what are the dependencies, what are the like base should be there, like whether it's the application will be based on the Python, Java, PHP or something like that. We will write all those in Docker file, and then we will get a Docker image. Okay, so it just like a template to create a Docker container. Okay, and also here you can see I mentioned one point like images which is created can be stored in a Docker hub. So there is something called as Docker hub where we get different images, different types of images, and then we can share those images to other developers, or we can use the, like images which is created by some other developers. Okay, all those things. So now to understand quickly or to get it easily, Like it's the Docker image, the concept is basically is the based on the OOPS concept, like the class and the object. Okay, if you are familiar with the object-oriented programming language, you may be in Python, Java, C++, okay, or any other languages, then it will be very easy to understand for you guys to understand the Docker image. So let me just simplify this for you. Suppose you have a one class called as students. Okay, sorry, it's not visible here. I just take some other. Wait. Let's go in general. Yeah. Okay. Suppose this one is your class. Okay. The class is students. Okay. Students is one class and it has some like properties or you can say their name, roll number, all those things are there. Like, okay. So what will happen? We can create different objects with this class. Okay. So we can create different objects. Suppose one object will be O1. Okay. Suppose this one is the O1 is the object. Okay. And then suppose we will create one O2 as the object. Okay. So this one is another object which we have now. So here we have, suppose we have object O2. Okay, cool. Wait, yeah, we have object O2. So like it just like now just think and imagine like it's just like the image. Okay, a student is just one image and we are creating different containers from that image. So I hope that is clear to you now. Like we just Docker image just nothing but a template which we will use and we will create then containers. Okay, so now moving forward, if we talk about the container, so container is nothing but just here you can see the running instance of the Docker image. Okay, it contains the entire package to run the application, like whatever the dependency, whatever the platform, everything, whatever is required, we will get in the Docker container. Okay, like just like if you suppose like what is the basic and what is the like main concept of the Docker. So it just it we just not just copy the code, we actually copy the whole environment. Okay, and we then pass it to the other person or the developer or other member of your team. So this is the simple concept of the Docker container. Okay, so whatever the instance which is run by the Docker image. Now in the summary which we have, the summary is nothing, it's just a very simple. So this one will be the Docker. It will be the Docker file. Okay, and with Docker file we will create Docker image. Okay, let me just create it for you so that it will be easy to understand. Okay, so this one is the cool. So here we will get the Docker image we will get. Okay, so here I have got the Docker image and then I will get the Docker container. Here we will get the Docker container. Okay, so this is the like basic overview and the basic concept of the Docker file, Docker image, and Docker container. Okay, cool. So I'm facing a little bit problem in this, so it's going in background. Just leave. I hope you got it. Okay, you got the concept. Okay, so that's it for today's videos, guys. I hope you liked it. Okay, and this was the basic concept of the Docker file, Docker image, and the Docker container. So that's it for today's, and I'll meet you in the next video in which we will be installing the Docker. So that's it for today. Thank you for watching. Hello everyone, and now in this particular video we will see how we can install the Docker in our this Windows system. Okay, so currently here you can see I'm on this particular website docker.com/injust/install. You can come upon on this by typing as well. You can just search on the Google like Docker install, and you will come upon on this screen. Just click on it, and you will be on the same screen on which I am. Okay, so now in today's video we will be basically installing for the Windows. Okay, so here are some different options as well for different OS like Linux, Mac. You can install on those OS if you want. Otherwise, if you want to install for Windows, so you are on the right place. Okay, so what we can do for Windows, you have to just click on this Docker desktop for Windows. So here are the some information which you will see like system requirements and all those things, WSL about Windows containers, everything you will see on this particular page. And this one is the button which we will use to download the exe. So we will get one exe file through which we will install the Docker. Okay. But before starting, you will need to first check the system requirement. Like it is important for us to install Docker. So the first requirement you can see it should be Windows 11 or Windows 10. It should be of 64-bit, and the version you can check here like it should be home or pro or enterprise or education, and it should be higher or 21H2 it should be. Okay, so to check the version you can just press Windows R, and you will need to just write type WinVer like Windows version, and here you will come up on this dialog, and here you can see the version. In my case it's 22H2, and the it is Windows 11. Okay, so same you can check in your computer as well. And also you can see here the enable WSL2 feature on Windows. Okay, so for this what you can do, you have to just open the command line and just type the command WSL. If it is there, it will show. If it is not, you can just install it using WSL hyphen hyphen install. Okay, so it will install WSL for you. So WSL is nothing but the Windows supported Linux. Okay, so it is required to install the Docker. Okay, and the other like general like 4 GB 4 GB RAM should be there, 64-bit processor should be there, and also virtualization should be enabled. That is also one point. So how you can check for virtualization, like it is required for. Okay, so what you can do, you can just hit Control Shift Escape. Okay, it will open your task manager. You will come up on this screen. You have to just click on the second one, performance, and then you have to go in the CPU, and here you will see virtualization is enabled. By default it is enabled, but if in your case it disabled, then you can enable it by going in BIOS setting. So you can follow some other tutorials for that as well. So for different PCs there are some different keys like F8, F5, F4, something like that. You can check. So I hope it is clear the system requirements and all. So now moving forward, you have to just click on this Docker desktop for Windows. It will start this one installer. It will start downloading this installer. Actually, I have already downloaded it. It's of some 600 MB. So now what we will do, we will just click on it, and you have to just hit yes, and it will take some time. Yeah, if you want to add to desktop, yeah, I want. Okay, so it will unpack some files. Okay, so just wait for the unpacking. Okay, after that it will try to install, and after all those things we will need to restart our PC as well. That is also one point. After that it will installation will be successful. Okay, so I hope you are enjoying this series of our Docker. Like in our previous video we have talked about the Docker file, image and containers. So I hope these all concepts are clear to you. If not, you can ask us in comment section as well. So just wait. Let's see till then. We just go through the what are the other things which we have here. For the WSL, we can check the documentation as well. So here you can see how we can install. So this is the command which we will use to install the WSL. So here you can see developer can access the power of both Windows and Linux at the same time on a Windows machine. That's what WSL game. Okay, the Windows subsystem for Linux. Okay, so sorry. So with that we can install many Linux distributions. We can install Ubuntu, Kali, Arch Linux, and all. Okay, let's check. Okay, so finally it's installing. Just wait. Yeah. So here it is saying you must log out of Windows to complete the installation. Okay. So let's do this. Alright, so here you can see we have got some error and it's showing we need to update the WSL. Okay, no problem. We will just copy this one. Create Windows R CMD, right click, enter. Click on yes. Just wait for the installation. Just see how much time it will take. 5% is now okay. So if in your case it shows log out, then you do log out. But again, just try to just restart your PC. Okay, otherwise it will show like Docker stopped. Just wait for the installation. 38% is done. So it's installing 54. Just wait, guys. Till then, I just pause the video. Okay, so here you can see Windows subsystem for Linux has been installed. It's showing. Now just close this one again. Click on Docker desktop. Just wait, and here you can see Docker desktop is starting. Okay, just wait. So it means we have successfully installed the Docker actually. And from here you can search for different images like where which we are talking about images in the in our previous videos. So we can use images for like which other developers have created. Okay, so here you can see to try running a Docker, copy and paste this command into a terminal and then come back. Okay, we will need to do this one, all those things, and the images, volumes, everything you will get here. Okay, so today we will just stop here, like our installation is successful. Now in our next video we will learn about how we can create images, all those things. Okay, so that's it for today's guys, and I hope you like this video. If you have any queries or you faced any problem, just tell us in the comment section. Okay, so that's it for today's video. Thank you for watching. Hello everyone, and now in this particular video we will see the Docker basic commands. Okay, as you can see on the screen, the heading is the Docker basic commands. Okay, so we will see these all commands to pull image, to run the containers, all those things we will see in this particular video. So before starting the video, I hope you have already installed Docker. It should be there in your PC to run all these commands. Okay, and also make sure you are running Docker in your background. Already I have opened up Docker here in my background. Okay, so I hope you have also opened it all as well. So to run these commands we need one c command line. So you can use just Windows CMD or PowerShell, whatever you want. It all depends upon you. So I'm using CMD here, normal. Okay, and if you want to use some other, you can use that by clicking on this plus icon, and then here you can set as Windows PowerShell and all those things. Or on this drop down you can check here I have Ubuntu as well. Okay, so all those things you can do. So I'm preferring here normal CMD. Okay, so currently I will just divide up the screen between two parts. Okay, to check the commands as well. Now I will first move into the different directory here actually. So we are here at the different directory. Yeah, and now to before starting the actual video, so you should know about the Docker Hub. Okay, what is a Docker Hub? Mhm. So basically, a Docker Hub is nothing but you can see as the marketplace of images. Okay, you will get many different type of images there. If you will search for Docker Hub, you will come up on this screen. Let me just increase the size here and just click on it, hub.docker.com. You will come upon on this, and here you can search for any image which you want. Okay, so today in this particular video we will be only using the hello world image. Okay, in our next video we will see some other images, like how we can use those images and how to run containers, how to actually use the UI or the console of that particular thing. Suppose if you want to install Python or use Python, then we will use Python image, and then we will do all those things. So just let's search for hello world for now. So hello world is there. Okay, and now what we will do, here you will see we have this image, hello world image. Okay, you have to just click on it, and from here you can find different things about this image. You can check for tags. What are the tags here? Latest is the share tags is there. Okay, now what we will need to do, we need to just use these commands in our CMD. So let me open up the CMD and the my Chrome browser as well, this one. Now let's start with the uh, first thing which we will do is the Docker version. We will check the which Docker version we are using. So currently here you will see we are using 20.1 sorry 20.10.23, and the build is this particular thing, particular number. Okay, so this is the currently version which we are using in our machine right now. So now the first command which we'll be using in this, now we will be doing pulling. Okay, we will pull the hello world image. So this is very simple. You will need to just do docker pull hello world. Okay, so in every programming language, whether it's C, C++, Java, Python, Swift, any language, I hope like you may have wrote the first program as your hello world program. Okay, so this time also we are doing the same. Okay, so just hit enter, and it will using the default tag as latest. It means the it is latest image or the latest version of that image, you can say like that. Okay, so here you will see we have currently pulled this image hello world, and now if you remember the concept of Docker image and Docker container, so we run a container from a image. So image just acts as a class and the container as the object. So now the thing is that now we will when we will run this image, so it will create container for us. Okay, so how we can do it, it's very simple. You have to just write this command docker run and the image name which we have currently pulled. So image name is hello world. So here you can see it successfully executed this command. So here you can see the content of that hello world image is the hello from Docker. This message shows that your installation appears to be working. All those things are there. And to generate this image, what Docker did. So all these things are mentioned in that image. That's why it's showing here. Now if you will see our the Docker UI. So let me open the Docker desktop. And here you will see one container is showing. Okay, so here you will see the logs. What are the logs were there? Okay, and the terminal, nothing is there. Inspect is here. Okay, files, here in this one file we have hello, name hello, we have one file. Okay, and here you can see the content of that file here actually. Okay, so now the thing is, if what will happen if I again run the command? So what, it will just create another container for me. Let's check. And if I do just clear the screen and again run the command, so here you will see one more container has been created. Okay, so it just like the class and the objects, these are the objects, okay, of the images. Okay, it means different containers are being run. Okay, so this one is about the creating a container and all those things. Okay, so I hope it is clear to you how you can pull the image and how you can then create a container from that image. So you have to just pull image using Docker pull and the image name, and you have to create the container just using the Docker run and the image name. Now next command we have in this list is Docker PA. So what it does? It basically shows the current running container. Okay, so currently it's showing nothing because we don't have any running container right now, because it is all the containers have started and it stopped and exited. So here if you will see on the UI, here you can see status exited. Okay, that's why it's not showing any kind of container right now. It shows us the current running container. We will see all those things in our next videos when we will be doing on the Python or some other image. Then we will see all those things, which containers are currently running and all those things. Now moving forward, if we will talk about the to check the list of all the containers, then we have an option. We get one as the A, or all we can say. If you will do A, so here you will see if I increase this one, and here you will see the container ID image is there, when it is created, status, all those things we are getting. So these are the two containers which we have created. Okay, so if you will check for the container ID, then you will see up here on the UI we will have the same ID. That is, if you will check for this one, it's 903, and above one is C44. So it is same C44 and 903. Okay, so in this way you can check the all the containers which are there in currently in the system. Okay, and similarly to check for images, you can check using the Docker images. Okay, so before that, let's check for how we can remove the container. Okay, so this is very simple. As you can see on the screen, we need to just use the container ID. So how we can do it? First, I clear the screen and maximize it to it should be clearly visible to you guys. So what is the command? Docker ps-a, or all, you can use anything. Sorry, we have not deleted, I think. Yeah, hyphen a. Okay, so now what we will do, we have to just use the Docker. Okay, and you have to use the rm and the id which you have to use, that is this one. So here you can see, if you will again check all the container, it will give you only one, and if you will go here and you will check, there is also only one container is there. Now again, to remove that container, you can use the Docker RM and that container ID. So you have to just copy it and paste it. Done. We are done now. Now there is no any container in our PC right now. Here also you will see nothing is there. Okay. So in this way you can remove the containers as well. Now moving forward in this tutorial, you will see for what are the images present in our this machine. So if we'll to go for Docker images, so here you will see one image is there, hello world image is there, its tag is latest, their ID is given. When it was created 17 months ago. Like you can see, like someone has created this image 17 months ago. Now currently in 2023 we are using this image. So this thing, for like, you can imagine how things have been changed, what are the like uses of Docker can be, you can think of that. Okay. And also here you can see in this column we have size at 13.3 KB. So now let's check for how we can remove the image. So it's also very simple. You have to just use docker rmi, that is remove image, and the image name which we have is hello world. Okay. So something happened. No, it's deleted. Now if we'll check for images, so no images are currently there in our PC. Okay, so that's all for today's videos, guys. I hope you liked it. If you have any queries, anything, you can just ask us in the comment section. Okay, so this one is the command which we used. Now in our next video we will check for the actual implementation and all those things with some other images. Okay, so that's it for today's, guys. Thank you for watching. I'll meet you in the next video. Thank you so much for watching. Hello everyone, and now in this video we'll be working on the Python image. Okay, so basically we are on this Docker Hub and we will search for the Python image here. So basically in this particular video we'll be working on the Python image, like how we can pull this Python image, how we can create the containers, and also we will see the interactive cell of the Python in this particular video. Okay, so let's start with the video. I hope you already have installed Docker Hub and all those things. And in our previous video, we have already covered the basic commands as well. So it would, there should be no any problem in that. So here we have on the Python. This is the one of the image of Python. Okay, so here you will see the command for pull Python. Okay, so we can pull the Python using this particular command which we have already covered. And these are the some tags which are used nowadays, like what version, if you want to suppose in your project you are using Python 3 point something, like 3.2 you are using, then we can use different tags for those all things. Okay, so let's start with the video. Okay, so let me open the CMD. Okay, and I will go in first 15, I think. Yeah. So here, let's check our Docker version first. Okay, so it's 20 dot something something something. Okay, so now what we will do, we will be installing, we will be pulling the Docker image. So the very simple command which you have is docker pull and the name of the image, that is Python. Okay, so we'll just hit enter and it will using the default tag, that is the latest is the default tag which is there. Okay, so it will install, it will take some kind of time. You can see here the size actually. Okay, so we will just wait for the installation. Just wait. And also one more thing, suppose if you want to install different version of Python, then while installing, while pulling the image, we can provide that different version using the colon, like docker pull python colon and the version name. It might be 3 point something. Okay, so in this way you can pull image of different version as well. So it's quite useful for us. Okay, so till then we just scroll the what are the things are here. If we get something interesting, let's search for it. Okay, so these are the simple tags we have here. Okay, share tags is there, quick reference. Okay, so here you can learn about what is Python. Okay, if you are new to it. And these are the some things which we will do in our next video actually. So we will create one Docker file, we will understand what are all those things, and then we will run one Python project as well in our later videos. Okay, in the Docker container we will do all those things. Okay, so let's check whether everything is installed or not. Yeah, it's installing. You can also search for JDK as well, like open JDK or JDK, something like that for Java, which we have. Let me search. I think it's open JDK. Okay. Uh, Yeah, here this one is we have it. So you can see it's 1 billion plus downloads are there for this one. Also, there are many things which you can see like Debian, MySQL as well. You can see everything is there, and based on the operating system, you can also select on which operating system you're working on. So it's very interesting thing, Docker Hub. Let's check whether it is installed or not. Yeah, it's finally installed. Okay, download a newer image for Python latest. Okay, so finally we have a image. Let me just go in here and we will search for images here. So here you will see we have one Python image. Okay, so now what we can do, we can just run this Python image. How we will run it? As we have discussed already, we can run it using Docker run. And the one more thing which we will add here right now is hyphen IT and the image name which we have Python. So what does IT refers to? IT just refers, so I refers to interactive and T refers to the terminal. So basically we will get the Python interactive terminal which we usually get. Suppose if you are going in, I open on another window of CMD. I think yeah, this is the another window. If I search for Python, so here you will see you are getting this terminal window or that interactive cell of Python. If you will here write print hello, then it will print. Okay, so in this way we will get as well there also. So let me just close it, and now I just run this particular command. Okay, so here you will see we are using 3.11.2 version, that is the latest one. If you will do something like print uh, hello, it will print. Okay, so if you want to do anything, like suppose if I do import os and print os.pwd, I think this is the command. No, it's not pwd. Something is the command which we use for the present working directory. Let me just search for it. If we go for OS library Python. Okay, so let's open gigs for gigs. Okay, so here you can see the cwd equal to os.get cwd. It will print the current working directory. So we can just copy it and I just paste it here. Okay, and I just to print cwd. Okay, so you are saying like we are on this particular directory, like the root directory. Okay, so in this way you can use the Python shell and all those things. Okay, so it was a very quick tutorial for you guys. So you learned basically about that IT flag. Okay, that interactive terminal flag. Okay, so that's all for today's guys, and in our next video we will be learning about how we can create the Docker file and all those things, and then we will create that images from that Docker file and then creating containers and running projects, all those things. Okay, we'll be doing in that particular video. So that's all for today's videos. I hope you liked it. If you have any queries, you can ask us in the comment section. Thank you for watching. Hello everyone. In this video, basically we will see some important concepts which are remaining from the basic commands video. Okay, so basically in this particular video, we will first see about the how we can run the container in the background. Okay, these all things which we'll see, and also we will cover in this video like how you can start the container, how you can stop the container. So these all things first we will see in the particular video. In the next video we will cover that creating images, then creating containers, all those things. Okay, so let's start with the video. Already in our previous video we have covered this one, like we have created that images, sorry, we have pulled that image of Python. Okay, And now we will create the container of that image. Okay, so just open the cmd. uh, Let me go into that directory where I do all those things. Okay, so now what you will need to do, actually first we will see the images. What are the images we have? So currently you will see we have on the Python image right now. And if you want to check for container, so currently you don't have any container. Okay, so the basic thing which we do usually to run the container, so how we do it, it's just simple docker run and the particular image name. So currently here we have the image name as Python. Okay, if you do Python, so what happened now? If you will check for container, so one container has been created and it is exited. So what happened with this container? Created and then exited. Okay, it's not running in the background. Okay, it is now stopped. So when you use this command, docker run Python, okay, and also which we had covered in the last video, that docker run hyphen interactive terminal and the image name. So here we will just wait for 5 to 10 seconds, okay, and I will just write the print hello. Hello is printed. Also something else, if you do class student and if you do just pass here, sorry, indentation error we got. If you do pass, okay, just control D, okay. So this thing you can do, like you have created a student as well. If you create the object of that class, you can do that as well. Print s1 if you do. Yeah, there you have the object. Okay, so now we just exit. Okay, now when we will see the this one, so here you will see this one. This is the container which is that. Okay, exited about a minute. No, no, this one is the one just exited 3 seconds ago. So we waited some time and then after exiting we it's showing 3 seconds ago. If you again check, it will show some more second, that is 26 seconds ago. And if you do just docker ps, so it shows the currently running containers. Okay, so currently you don't have any container running. Okay, so to execute or to run the container in the background, we have some different flags, okay, which we use. So the very special flag we have is the hyphen D, that is the detach. Okay, we use this flag to run our containers in the background. So how we can do it? It's a very simple to use, and also you will learn about some what you can say one more flag, that is the hyphen name. You can give any particular name to the container as well. So how we will do it? So if you want to do first, I just do ps hyphen a, I just remove these containers for now. So how you can do it? Docker rm, and you have to just provide this. Okay, done. Again, let me just copy this one. Okay, okay, let's check again. Okay, we don't have any container right now. So now we will just create a container and it will run in the background. How we can do it? So you have to use docker run, and the flag which we'll use for now is it, that is interactive terminal, and the name we will use. So I will give the name to the docker is ps. You can pc, you can give it like that as well or like this as well, it doesn't matter. Okay, so I'm using this simple method, that is ps without quotes. And we will use the hyphen d flag, the detach, and here you will need to provide the image. Okay, the name of the image which you have pulled. So image name is this Python. Okay, so here you will see some kind of long string. It may be docker id, it sorry, container id, it can be. Let's again search for docker ps hyphen a. So here you will see the details about the container ID, the image, the command which is basically used when we do IT interactive cell, when we do it. 28 10 seconds ago, status up 9 seconds. Here you can see up, it means it's running, and the name you can say is PC, which you had provided right now here. Okay. If you do now docker ps, it will show you the running container. So currently the running container is this one, which is that. Okay, that is 5D something is the ID which we have got already here. Okay, so now moving forward, if you want to execute that container, how you can do it? For that also we have the command that is means execute. You can pronounce it like that. Like we have exec, and here you will need to provide the IT cell, that is interactive terminal flag, not shell, and then you will provide the name, and after that you have to just give the which command you want to execute. So currently we want to execute this python 3. Okay, so if you do python 3, so here you got it. You got the terminal that you can do print anything. Okay, so in this way you can use the containers and you can run the containers in the background. Okay, so now what we will need to do later, right now we will see how you can stop the container as well. For now I just exit from this interactive shell, and I'll just clear the screen and check for PS running, and now I will do this stop. So how you can stop? Docker stop. Here you can provide the name of the container or just a container ID. It takes some approx 30 seconds of time for stopping the container. Okay, just wait for it. Okay, so now container has been stopped. If you again go for ps something, so here you will see there is no running containers for now. If you do ps-a, so the container will be there. Again, if you want to what we can say, start the container, how you can do it? It's simple. Just instead of stop you can use this start. Okay, so now if you go for ps, that is running container, so we have that this one up 9 up 4 seconds. Again, if you do 9 seconds, 10 seconds, 11 seconds, 12 seconds. Okay, so our container is running. So I hope you got it, how you can execute the command, or how you can start the container, stop the container, run the container in the background. So these were some important concepts of the Docker, okay, which we had by mistake left. Currently now it is covered. So in our next video we will surely do that one, creating Docker file and creating image and then all those things particular. Okay, so if you have any query you can ask in the comment section. Otherwise that's it for today's video, and I will meet you in the next one. Thank you for watching. Hello everyone, and now in this video we will talk about how we can create the Docker file for the Python image. Okay, so here you can see the different keywords I have written for you all. Okay, so these are the some keywords which we use for creating the Docker file actually. So in this particular video basically we'll be creating the Python image. Okay, so here you can see actually the description is also written for these keywords. You can see the from keyword is used to use the base image. Okay, what are the base image which we are going to use here? So mostly in the from keyword we specify the base image. For Python we will be use Java. For Python we will be use Python base image. For Java we will be use OpenJDK. For the Ubuntu we will be use Ubuntu image. Okay, so these are all the base images which we get from the Docker. We will be using those kind of images. Okay, and run command is also used to run some kind of commands which you want to run while creating the container and all. And copy used to copy the files from the local file system to the Docker image. Work dir used to set the working directory for the container actually. Okay, and cmd is basically used to specify the what are the commands you want to run when that particular container runs or something like that happens. Okay, so these are some of the I think 3 to 5 commands or keywords which we'll be using in our Docker file. Okay, so before starting the video you should have VS Code installed, or you can use any ID, not ID, it's just what do we say, notepad or something like that. Okay, or editor you can say. So here I have this docker tutorial folder, and I'll be creating one Python image folder. Okay, so let me just cancel all those things, And now what we will be doing, we will just create one Docker file. Okay, you can do like this Docker file, and keep in mind, like you should use only one capital D here, not the name should be like this only. Okay, so here is the Docker file has been created, and let me create some app.py as well. Okay, so this is the Python file, and suppose you want to just print like this is my first image. Okay, cool. So this is done. Suppose till now we just want to print this in our container, like when our container will run. Okay, now what we'll be doing, we'll be creating the Docker file. How we can do it, you have to just use from, and from which base image you want to use. I want to use simple Python. Okay, you can use from Python. After that, you can specify the working directory for that particular container. So I just want working directory to be app. Okay, and also you want to copy all the files, okay, to the app here. Okay, and next we'll be using the cmd. Okay, now currently we don't want to run any kind of command. Okay, that's why we are not using run here. So in cmd, what we want to use this line python 3, and you can specify in a comma you want to run which file. I want to run app.py file. Okay, so this one is done. Okay, that much is fine to create the python image. Okay, so now the further step is just to use to build that build the image. Okay, actually from the docker file. So you have to just open up the terminal here. You can click on this and click on this here, docker terminal, and you have to go in that particular directory. So we are currently in python image, so we are here in that directory. And for building the image, the command which we use is docker build, and one hyphen t flag is used to define this some kind of tag. Like the default tag which you get is the letter. So here you can define any tag, suppose like my first python app, and in that also it should be only in lowercase. You cannot give the combination of uppercase and lowercase in the tag name. Okay, and then we'll be using dot will be used to just get the docker file and then creating that image from that. Okay, just hit enter, and here you can see our image has been created actually. And this one you can see exporting layer, writing image, this one. Okay, naming my first python app, this is done. Okay, now I will just clear this screen, and I will just run that particular image. So image name was I think my first python app. So it's running. So here you can see it is printing, this is my first image. Okay, and if you go on the docker desktop, so here also you will see the name is this one. It is just specifying that random name it specifies, and the image name is my first python app, and image also here you can see the my first python app. Okay, so in this way you can create the python image. Now let's do some, what we can say, some kind of not experiment, just I write some commands actually here. Import os. Okay, and I want to just show you the actual directory, inverse directory that docker is running. Okay, so here we can write current dir is, and here comma separator os dot get cwd, and here we will be using this one. And again I want to just run the build image, and I will build it. Okay, and the container name I want to provide, name of container is hyphen hyphen name, and it should be like uh, what should be the name? Uh, first py, first py c means first python container. Just hit enter, and here you will see this is my first image is printing, and current dir is slash app. Okay, and here if you will see here also like okay, none is showing. We will see why. Okay, tag is none. Okay, okay, no problem. In containers, if you see, yeah, in container her name is first pyc. Okay, the container name actually. Okay, so now what we will do, again if you want, so I just want to create one file here. Suppose I create one file hello.txt here, and I just print a hi here, and I want to print the list of directories or files which are present in that Docker image, because we are using the copy here. Okay, so it will copy all those things in the Docker image. So for this we can use os.get, not get, I think it's list dir. Yeah, again we will just here I use some different tag, uh, list list I just do list image. Okay, okay, and now I run this using list image and the second py container, enter, and here you can see it is listing the all the what you can say, all the files and the current directory, and the print statement is printing. Okay, so in this way you can create the any python image which you want, and suppose you want to send this file or something like that. Suppose here is some kind of project which you have get in that file, and you want to send to the other person, so you can just create the image of that file and you can send it. Okay, so in this way it works. So I hope you liked this video, and that's all for today's videos guys, and if you have any queries you can ask us in the comment section. Okay, so that's it for today. We'll meet you in the next video. Thank you for watching. Hello guys, and now in this particular video we will see how we can create the Docker file for the Ubuntu image. Okay, so basically we will be using all this command which you are able to see on my screen, like from, run, copy, workdir, cmd. Okay, so basically we will be using some of the commands from that, and we will create one Ubuntu image, okay, from the Docker file. As you have already saw in previous video, in the Python we have done it, so same thing which we have to do in this as well. So what we will do, we will be just creating one directory with the name Ubuntu image, and inside that let's create the file, Docker file. The name should be only like this, and then what you have to do, you will just use this one from. Okay, and then what you have to do, you have to just write the image name as the Ubuntu, and then what you have to do, we will use run command in this actually, and we will update the image. Okay, whenever the image will be created it will update it. Okay, our Ubuntu will be updated, and then we will be using cmd, and then we will write some command, like we can write who am I. It will tell us the who is the current user, the name of the user. Okay, so now what we will be doing, I'm already in this directory, and we can do like this, like docker build hyphen t. You can provide any tag name, it's all depend upon you, Ubuntu app, and then we will use dot, and it will start. Okay, so now it's done, I think. apt update also didn't take much time. Okay, it takes usually. Okay, fine. Let me just clear the screen, open up the cmd. Okay, you can do anywhere, you can do on this terminal as well, but I prefer doing on this. So if you'll do docker images, and here you will see Ubuntu app. So this image has been created, I guess. Let me just check what was the image name. Yeah, Ubuntu app is the image name actually. Okay, so now what we'll be doing, we will just run this image, docker run, and we will provide some name as the my first Ubuntu. Okay, and we will give it the image name, that is Ubuntu app. Yeah, so here you can see the root, so it is giving us the result root. Okay, so like the command has been executed. So which command has been executed? This who am I. If you will check in the containers, so here you will see the command who am I, and the image is Ubuntu app, and the name is my first Ubuntu. Okay, so now let's just change the command. You can do any command, like suppose if I do some comma and write some another command, what will happen? Let's check. It will just give us error because it will execute in a single command line, I guess. So it will give us error. So instead of that, we can try like this pwd only. Okay, and we will create with the name Ubuntu app 2. Okay, so it's done. Again, open up the terminal, and if we'll clear the screen, and let's check for Docker images. Okay, Ubuntu app 2 is there. If you will do a Docker run hyphen name, same name, let's give same name Ubuntu 2, and the okay, so now let's hit enter. So here you will see the present working directory is the root directory. The forward slash means it's in root directory actually. Okay, so that's it for today's videos, guys. I hope you liked it and you got it how you can create the Docker file for the Ubuntu image. Okay, it's simple. Okay, so that's it for today, and I will meet you in the next video. Thank you for watching. Hello guys, and now in this video we will see how we can create the Java image, okay, using the Docker file. Okay, so here are the some of the commands which you can see on this screen. We have from, run, copy, workdir, and cmd. Okay, so basically we'll be using these commands. Okay, and we will create one Docker file, we will create one one Java project as well, and we will run that project. Okay, and we will check the output in the Docker, like how we are getting. So it's a very simple step to do. For that, again, you will need to create one directory. Let me just create outside this. Yeah, here we can create. It's fine. Java image is there. Okay, so you have to just create one Docker file. Fine. And then we will be using next command we have is the workdir. So basically, we will define the directory. Okay, fine. Then we have copies there, so it will basically copy the all the contents of the file or the current directory, and then we will see we basically run one command. I will explain it to you. Let me just write sample dot java, and then we will use cmd. Okay, and we will use java comma sample. Okay, so we are done. Okay, Docker file is done. So now let me explain you why I have written this sample.java. So now I will just create one file with the name sample.java. Okay, and I will just create the class with the name sample, and then we will be using public static void main. Java syntax is very lengthy, but it's fine. We can do it. The system.out.println, and then we will just print hello world. It's working fine. Okay, cool. So now what we will do, we will go into this directory in the Java image, and we'll clear the screen, and the simple thing which we have to do is to just compile this Java file. So if you are a Java programmer, you might be aware of that. Before actual running that like Java program, we need to compile first, because it's I think compile based programming language. Okay, and then we get one file, then we run that file, then it is executed. Okay, so we will just compile this one. So we will compile using Java C program, sorry, Java C command and the sample.java, and we forgot the semicolon. It happens here. Okay, So here you can see the file has been created, and we have to just give the name sample, and here you can see the result is hello world. It's working. Okay, it's fine. So because it's working, so now what we will do, I will just explain it to you. So basically the run command is basically the command which is run when you create the when you run the image actually. Okay, so it will just first compile, and then what we are doing, we are just running the executing that compiled code, okay, using this command java, and we are providing the file name as the sample. Okay, that's it. This is the only concept behind this. Okay, fine. What we will do, we will first build the file, build the image using this docker file. How we can do it, docker build, and we'll provide the tag name using -t flag, and we will write the name as my java app. Okay, just dot at the end. Okay, it's working. It will take some time, and something happened. What we are getting, sample dot java command not found. Okay, fine, because we have not written java c here. Okay, that's why it was just a basic one. Let me again run. Okay, now it's done finally, and we will just clear the screen. We will open up the CMD. We will search for the Docker images. Okay, so here you will see my Java app has been created. Now what we will do, we will basically run this image. We will provide the name of the container as the what we can provide. Uh, Java Java 1. Okay, fine, it's fine. My java app is also, we can give the image name. Okay, let's see. Okay, so here you can see we are getting the output as the hello world. It's working fine. It means like it's working perfectly. If you want to check the container list, so here you can see the using ps-a, and here you can see it's created just 11 seconds ago. Okay, exited this one 10 seconds ago, and the name is java 1. Okay, fine. Again, if you want to let's we can do something else as well. We can try to create calculator. I will just copy the code of calculator. Why to write the whole code if you have code? Don't take it seriously. Okay, so here what we can do, I have just copied it, and we will just paste it here. Control V, and they change the name as sample. Again, I will just first run this app. Let's see how it's working. Java C sample dot java. Let me again delete this one. Okay, and let's run java sample. Okay, will choose plus. I will 12 11. Okay, it's perfectly, it's working fine. Okay, so now what we will do, we will be just again creating image, docker build -t cal c dot. Okay, fine. Now what we'll do, we'll be on terminal. Let me just clear the screen. We will check for docker images, and its calc is there. It's created, you can see 12 seconds ago. We will just run this application. We will do docker build. Sorry. We will do docker run. We will provide the name, one name like calc app in Java. Okay. We will provide the name of the application as my Java. Sorry, what was the name? Calc is the name. Fine. Okay, let's see. So here you can see choose an operator because we are getting something else. We will need to run this application in the background, guys. Okay. Mm. Okay, we can try with detach mode. Okay, let me just clear the screen. We can do docker run -it name. Let me first check the name whether any, yeah, container is created. Okay, we will delete this one. Docker rm, you can delete the container using the container id and the rm command. Okay, let's do. Now it is deleted. Yeah, I guess, yeah, it's deleted now. So now what we will do, we will run the image, that calc image. So we will do docker run hyphen it hyphen name. We can give it as the calc app. Again, we will do hyphen d for in detach mode. It means it will run in the background. Again, calc is there. Let's hit enter. Let's do docker ps to check. Yeah, so here you can see it's running in the background. Okay, fine. Let's try to execute docker execute hyphen it, and the container name is, we have container name as a calc app. Okay, okay, but here we need to provide the command name actually. So we can provide a Java sample. Let's see what happened just. Okay, so choose an operator. So we will choose operator s plus. Enter the first number 12, 13, and it's working perfectly fine. So in this way, you can just execute these type of programs in the background. Okay, so that was a very simple actually. So now, if you will check again, if I'll clear this screen and again run this one, and I choose suppose into first number 12, 12, 144. Yeah, cool. Clear the screen. It means it's working fine. And to stop the container, you can use here the container is running. So to stop the container, you just have to provide the command docker stop, and you can provide the container name and the, or you can provide the what you can say, this one, the name as well. Then it will stop it. And if you will check, so here no container is running. Okay, it's perfectly fine. So in this way we can do all these things. So it was a very good video, I guess, but you guys will tell how it was. Okay, so if you have any query, you can ask in the comment section. Okay, and that's it for today, and I'll meet you in the next video. Thank you for watching. Hello everyone, and now in this video we will see how we can push the image to the Docker Hub. Okay, so these are some of the steps which we have to follow to push the whatever we create the image for the Docker Hub. Okay, as it will be very beneficial. Suppose if you want to send some code or some part of like some of your project to someone else which works on a particular environment. Suppose that project works on Python 2.6 only. Okay, so then you can create the image of that, and then you can send it to your friend, or like you can post it on the Docker Hub, and from there your friend can access it. Okay, so this is the very simple process. So for that, first of all, you will need to go on this particular website, that is Docker Hub. It like hub.docker.com. Okay, and here if you don't have any account, then for that you will need to register first. It's very easy process to register. Actually, I have already an account on it. So what we can do, I will just sign up, sign in here. So this is the username which is required to push the image to the Docker Hub. Okay, so currently we are here on the dashboard. Okay, so now what we will be doing, like we had created the image, that is calc. Okay, and now we can do, we will create one more image for this project. Okay, that's sample.java. Okay, we have already the Docker file here. We had done it in our last video. Okay, so this is the Docker file. So what we will do, we will basically create one image. Okay, so how we can do it, it's very simple. Docker build hyphen t. Okay, and the name which you want to provide, suppose I want to provide its name to calculator Java. Okay, this name I want to provide, and you have to just use dot. Okay, so here you can see image is being created. Now if you'll search for Docker images, so here you will see calculator Java has been created, and the tag is latest because we had not provided any kind of tag to it. That's why it's showing latest. Okay, so just clear the screen, and again let me just search. Okay, so this is the image has been created. Okay, So now here if you will check, here you will see the whatever the image we create, we don't provide the actual the format of that. So we need to change the format using this command like docker tag and the whatever the image name, if version name is present, then we write the version name and then the name in the format in which through which we can post that image to the docker hub. Okay, so that how we can do, let's see. So it's just you have to provide docker and then you have to provide the tag and the name of the image which you have created. So here the name is calculator java. Okay, so calculator java. Okay, and the name will be followed by your username. So my username is 987456 slash and whatever the name which you want to give. Suppose I want to give it as the calculator app, and I will provide the version. So I will provide the version name as version 1.0. Okay, let's hit enter. And now if you will again search for docker images, you will see one image has been created with the name and the tag is version 1.0. Okay, so now what you will need to do, you will need to just do docker login, okay, to push that image to the docker hub. So docker login is required. Okay, so here it is showing me like I'm already authenticated here. Okay, so if I will open up some new terminal and if I will search here docker login, okay, it's already my account is already authenticated, that's why it's not asking me for the username and password. But when you will do it, you will need to enter your username and the password. Okay, so it's fine. Now what we will do, the last command which we will use is docker push and whatever the image name which we have. So we have this image name, we will need to copy this whole. Okay, so okay, push and the version name which you will need to provide is, and the version name is version 1.0. Okay, so here we're done. So the push refers to repository this, so it will now push our project to on the docker hub. Okay, let's wait, it will take some time. So it's of 323.6 MB. Okay, so here you can see it is showing me mounted from Ayush this Calci app. Okay, so is there also any, no, actually I had already pushed one image with the same name for the testing, that's why it's showing that. Just wait till the completion, I just pause the video. Okay, I will come back when this will complete. Here you will see now it is pushed. Okay, so if you will check here, if we reload this, okay, so here you will see one image is pushed here. Okay, and this is the same name which we had given like calculator app. Okay, and if you'll click on the public view, you will get to know how you can pull this image. Okay, so this is the command which we use to pull the image actually. Okay, so that is the simple one. Okay, so you might get confused why mounted and all. So to clear all this, if you want to, you can give it like this colon and then version 1.0, but now I don't want it, just hit dot. Okay, so let's just clear the screen. If you'll check for docker images, so here you will see this one Ayush 987, this. Okay, oh sorry, not this one. Yeah, here we have hello python. Okay, so this is created. Now we can just push it using docker push, and the name which we have is Ayush 987456 slash hello python. Okay,
So here you can see it is preparing and waiting. It will take some time. Okay. Okay, it is now taking all the from library Python. Fine. Okay. I just pause, okay, and we'll wait. I just pause. Okay, so here you can see it is just pushed all those things. If you will check again on the repositories here in this section, and here you will see hello Python is there. And if you click on public view, so this one is the command which we'll be using. Okay, so now what we will do, I just go into the Docker images and I just remove this one, Docker RMI remove image, and the name of the image should be, okay, okay, now removed. If I can check, okay, fine, there is no images. So now what we can do, where is the, yeah, instead of RMI we can do now pull. Okay, so now it's pulling the resource from the Docker hub. Okay, status downloaded. If you will again check for Docker images, so here you will see we have this one, and now if you want to run, you can run it using Docker run and the control V. If you do this one, and the, here you can see the content, whatever the content we had written, it's showing us here. If you'll check app.py, so this is first image, current directory is printing, and the all the files which are present there. Okay, so in this way you can push the image to the Docker hub, you can pull the image from the Docker hub. Okay, and also this will help you to what we say, you can easily share your project to other person as well. Okay, so that's it for today's videos, guys. I hope you liked it. Okay, if you have any queries, you can ask in the comment section. That's all for today's video, and I'll meet you in the next video. Thank you for watching. Hello guys, and now in this video we'll be talking about the Docker Compose. Okay, so this is the very interesting topic, and till now we have actually covered the very all the basic concepts of the Docker, like from creating from pulling image from the Docker hub to pushing image to creating your own custom image. Everything has been clear till now, and now we will be moving towards some advanced topic, that is now the current we have is the Docker Compose. Okay, so let's see what are the information about the Docker Compose on the documentation. Okay, so here you will see so here you will see the overview of the Docker Compose, what Docker Compose is, how you can install, try compose, everything, all the information is here. Okay, so let me tell you first about the what exactly the Docker Compose and why it came in the role. Okay, just think about the web application. Okay, suppose if we have a one web application, if we come here and if I create some, just suppose this is one of the website. Okay, this is one website. Okay, and it's suppose e-commerce website or any dynamic website, you can say. It will be the front end and the back end as well. Okay, so what will happen if you want to just run this application in the containers wise with the through with containers and in Docker. So in that case, you will need to create two different images, one for the front end and one for the back end. So in this way, like, it will be very difficult to manage both the containers at a time. Okay, so that's why that Docker Compose came in a role. So with the help of that, we can run these two containers at once and we can manage it easily. So this is the very basic and fundamental concept of the Docker Compose. If you'll come on the documentation part, and here if you'll run, sorry, if you'll read, so here you can see the Compose is a tool for defining and running multiple container Docker applications. Okay, with Compose you use YML file. So we basically use one YML file, that is docker compose.yml. It is the one file in which we define all these things like images, what images you have to use, and all the like connecting parts, all those kind of things. It is managed by the docker compose file, that is .yml file. Okay, so with this file we manage the containers. And here also you can see here it is written like with a single command we can create and start all the services from your configuration. Okay, so this is also one of the parts. So if you will come upon here, you will see how you can install compose, try compose, all those things. So we will cover all these things in our next video. So that was the basic overview of the Docker Compose, and what we got to know is the .yml file is first important file, and it is basically used to run the multiple containers at a time. If you need like if you need some more information, you can just search for Docker Compose and any medium you can search. Okay, so here you will see many people post about the Docker Compose, what is this, or you can read this blogs by he is someone Farim. Okay, so here you can see all those things. Okay, so that is the basic overview of the Docker Compose. I hope you liked it, and we'll be surely updating in our next video the further part of the Docker Compose. So if you have any queries, you can ask in the comment section. So thank you for watching, and I'll meet you in the next video. Thank you so much for watching. Hello guys, and now in this video we'll be talking about how we can create the docker compose.yml file for this docker file. Okay, so basically we will be creating that file. That will be the simple one for this video for now. Okay, in the next video we'll be look for some complex, okay, where we can manage the ports and all everything. So docker compose.yml you have to write like this, and it has also some kind of syntax and semantics to write this file, just like the docker file which we were running from first from, then run cmd copy, all those things. So similarly in docker compose also we have some syntaxes. So what is the syntax? Let's see. We will just write okay, so the very first is we need to provide the version. Okay, version is basically which version of docker compose you want to use. So currently we had checked, so it's our 2.5, so we will write it 2.5. And then later on you have to provide the services. So here you will provide the services, and next you will provide with the service name. So service name we can provide anything like let's provide ubu. Okay, it's Ubuntu or Ubuntu image, like this we can provide. Okay, and next you will need to provide some container name. Okay, so basically we'll be creating file for building the image and then running that container, do those things. Okay, so how you can do it now, you have to just provide container underscore name colon space, and let's write something my container. Okay, and next you will need to provide for build. Look for the building of with the docker file we use build hyphen t, then the tag which we want to provide, and the context, that is the directory in which directory we have. So for that here also you will need to provide the context actually. So context will be the dot, and the next docker file. So docker file will be the docker file which we have, that is this one, and that's it. And now we are good to go. So you will need to just enter the docker compose up, and here you will see it is building. So here you can see, and now container, my container created attaching to my container is printing high. Why? Because so if you will check here, so we have printed echo high, that's why it's showing high. Okay, if you just clear the screen and you check for the images, so here you will see image might be created with, yeah, here you can see Ubuntu image with the name it is created. Okay, and if you will check for the container as well, let me open up the cmd in the full screen mode. If you'll check for docker ps-a, so here also you will see the one container just 35 seconds ago had created. Okay, so in this way you can write the YML file of Docker Compose. So this is the basic syntax for the version, and this is the service, this is the service name, And these are the some key value pair which we need. Okay, for building the image we need this one. For ports, to defining ports and all, we write for ports, these things. Okay, so in the next video we will see some more complex. So that's it for today's videos, guys, and I hope you liked it. And if you have any queries, you can ask in the comment section. Thank you for watching. I'll meet you in the next video. Thank you so much. Hello guys, and now in this video we will see about the Docker Compose installation. Okay, so before starting the video, there is a good news for you. Like if you are using Windows and the Mac OS, then it comes already pre-installed when you install the Docker in your system. Okay, so currently in this video we will be seeing how you can install in the Linux system. If you are using the Docker in the Linux system, then you will need to install that. Okay, so for that you will need to just search Docker Compose. If you search your installation, and here you will come upon on the official documentation of the Docker, and here you will need to open up here, and here you can see the overview of the page of this one, Docker Compose, and here you can read the documentation about all those things. Like for Linux Mac they are saying to install the Docker desktop, and for Linux as well, like it is required, I guess. Yeah, here you can see if you have already installed Docker desktop, you can check which version of Compose you have by selecting about Docker desktop from the Docker menu. Okay, no need to do all those things. Let's just quickly check the Docker version in our PC. So here if you'll do Docker Compose -v, so here you will see we are using the version 2.15.1 Docker Compose. Okay, so in your PC as well it might be same or it might be different. Okay, so let's see how we can install in Linux. So for that you will need to come up on here, and you will need to just click on this. You can install the Compose standalone, and here you will see the some of the commands which will be used to install the Docker Compose in the system. So here you can see the curl command is there, and here they have provided the some links, and also the steps, what are the steps you will need to take to install the Docker Compose. And also this sudo command is there for, I think, creating symbolic links is there. This is for the Linux. And if you will go to scroll down, and here you will see for the Windows Server as well they have given the documentation, so you can read it and you can install the Docker Compose easily in your system. So if you are using Windows and Mac, then it's fine. Otherwise you can install in both of these, Linux and Windows Server. Okay, so that's it for today's, and I'll meet you in the next video. Thank you for watching. Hello guys, and now in this particular video we will see how we can create the Python server using the Docker Compose. Okay, so for that you will need to first create one directory. Let's create a Python server, and inside that we will need to create first one Docker file. So it's very simple, you can just write like this, Docker file, and in that we'll be using Python as a base image. Okay, and also I will create some file here, like I will create one hello.txt, and here I will just write, hi, this file is inside the Python server directory. Okay, fine, cool. So now what we will need to do, we will need to first copy all these files. I want this to copy all this in /app, and work dir should be as well /app. Okay, so let me just check it is correct. Okay, okay, fine. Now we will write like this, work dir first and then correct. Cool. So now our Docker file is ready. Now we will need to create one Docker Compose file. Okay, so how you can create Docker Compose .yml. Okay, so inside there you will need to write the version. You will need to specify the version. So version will be 2.4. Okay, then services you will need to provide services. So inside services you will need to write the service name. You can write service name as my first server. Okay, and inside that again you will need to write the container name. So you can write like this, container.
underscore name colon server. Nice. And then command which we'll be using to run the server. So the command which we have is python 3 hyphen m http dot server, and the port I will give it as 1234. Okay, and here you will need to allow the ports from your system as well. So for this you will need to write minus dash 1234 colon 1234. Okay, now you will be writing the code for the build which we use to build the image. So build will be as simple as it is. So we will need to provide the context. So context will be the current directory, and then the docker file you will need to provide the docker file as well. So which we have docker file as this one, docker file. Okay, you have to just save, and now we will run the docker compose up. So for that you will need to go into that directory, sorry, no, python image cd python server, clear the screen, docker compose up. Okay, so here you will see we are getting some like non-string key in services dot my first dot port 01234. Okay, for this we will need to just remove this space, I guess. Now it will work. Yeah, cool. So here you can see python server is default, containing server, container server created, attaching to server. All those things are working. Just check. Okay, now let me just open up the Chrome, and if I go on localhost 1234, and here you can see directory listing for this docker compose.yml file is there, docker file is there, hello.txt is there. If you click on hello.txt, here you will see this file inside the python server directory. Okay, so in this way you can create the python server using the docker compose. So here you can see the everything you can see here. Okay, so that's all guys for today's video. I hope you liked it. If you have any query you can ask in the comment section. Thank you for watching. I'll meet you in the next video.
Hey everyone, in this video I will show you how to create and deploy a basic static website. Okay, so I'll be using a simple HTML, CSS and JavaScript as this is our the first project. So this will be the static website in which something will be related to the AI. Already I have created the project with the help of DeepSeek. You can use any other AI model which you want. Otherwise, I will be pushing the source code of this files in this directory. So I will keep the link into the resource section. From there you can access this repository. Okay. So what we'll be doing, the agenda for this video is basically we'll be creating a Docker file and we'll be using the base image as Nginx. So it is basically a web server. Okay. So web server which is used to host websites. So basically Nginx is used to host the static websites. So we have two types of websites, that is static and one is dynamic. Okay. So static websites where no actions is required, like no form, what we say, we will not be submitting any kind of form, we will not be doing any kind of action on the website, like adding something like that. Okay. So it will be a very simple website. And next is the port will be exposing to 80, as this thing already we have discussed in the previous classes. So if you have any doubt, then you can ask us in the like section which we have forum, right? So let me show you the website which I have created. Okay, so you can first let me show you the project structure. So project structure basically I have created direct Docker project, and in that I have created a project one, and in project one I have all these files, index, style, script, and images. Okay, so let me just show you. So if I click on index.html, it will open up in the uh, browser. So but the URL you can see it is just referring the files. Okay, so this is the basic website home.
If you click about it will give me all the information, a application and everything. Okay, if I just reload it, then and come down this everything you can see how it is happening. Okay, it's looking quite a nice, good looking website. Okay, so we'll containerize it. Okay, so let's begin. Mm, okay, this one. Yeah. Okay. So the very first step which we do, as we already know, we'll be creating a Docker file. And in Docker file, I'll be using the base image of Nginx Alpine. Okay. And basically what happens in Nginx, we have a directory with this name, like the full directory structure is user share Nginx HTML. Okay. So at this directory, we'll be keeping our files. Okay, so we use the copy, and dot refers to the whatever present in the current directory. So in my current directory only the project files are there. User share nginx html. Okay, copy added. After that I have to expose it, like my inside the container, my website will run on the port, on what port it will run. So that I have to write here, that I want to write is at 80. And then this command, I will be writing like when the container will start, that time what command should run. So the command is nginx comma -g comma daemon off, right? So this is our simple basic Docker file. So let me just build it. So already I've created one AI with name AI. I'll be using static website. Okay, okay, it is done. It got build everything. Then I'll be using Docker run command, and we can use the image ID here, and the port I will be using 8081. That is perfectly fine. And here I'll be adding static web. Okay, cool. To Docker PS. Okay, here you can see static web is there. Okay, it is running on port 8081. Let's go in the browser, and I'll be opening the port 8081 127.0. Change the port here. Nice. So here you can see now your application containerized, and it is running on the port 8081 on your local host. If you deploy the same thing on any server, so instead of the local host, you need to keep the IP address of that particular server. Let me just tell you some more about like if you want to deploy this project on AWS. Okay, if Docker is present there on that particular server. So basically in AWS, what happens? This we have the public IP and the private IP, right? So with the help of the public IP of any E0 instances, you can just access this website. So those things we'll be covering in advanced project when we'll be creating. So this is the that's it for today's class, and let's see you in the next one. Thank you.
Hello everyone, welcome to this class, and today is the third day in which we'll be creating our project 3. So before going further, let me tell you about what is this project about. So it is a basically a project with Node.js and the PostgreSQL. So basically in this project, if you will, I have created a API, you can say, and if we hit different endpoints, then something will happen. If you go at root endpoint, then you will get a response or some text response you will be getting on the screen. And another endpoint we have, that is if insert data. So at this endpoint, we are running a insert query, and it will insert your data into the DB, that is your PostgreSQL, and the table and all will be creating. So I will show demonstrate you the project, how it is working. So I'll push it to the GitHub repository. From there you can access the project and you can install the modules. So next thing is we'll be talking about means what are the things of Docker we are going to use. So basically in this project I am going to use first the Postgres DB which we created in the last class. Okay, Postgres DB will be using. Next is we will be using Docker networks. That is the first thing which we are going to use first time in this project. So Docker networks we'll be using. So let me just tell you a brief or quick introduction of Docker networks. So as we have already discussed, so Docker networks is like we will be running the both containers on the same network, and we will be able to communicate between these two containers. Okay, it will be not like one container is on network A, another container is on the network B, so there is no communication between it. Okay, so we will keep the both containers on the same network C1 and C2. So we will be keeping our Postgres container on the same network and the same Node.js container on the same network, and also we'll try to do ping if possible, then ping with IP address so that we can see whether both containers are communicating with each other or not. So this is the basic idea of today's project. So let me just quickly go through the project. So what you will be doing, so basically we have this app.js, and here I'm using Express and PostgreSQL as we already discussed, and this is the same username and password which we were using earlier, and this is the uh, root path where we are just sending hello GFG learner, and insert data is there. So here we will be inserting some data into this items table which we will be creating. Okay, so let's just exit from this, and what we'll be doing, I will simply run this project using node app.js, and we can go into the browser and open the localhost slash 3000. Okay, this is the path you can see, 3000 is there, and let me just open up another terminal, and what we'll be doing, we'll be restarting our the Docker container. Sorry, not this. We'll be doing docker ps hyphen a grep. Yeah, okay, already Docker container is running, so we'll be executing means we'll log into it, and we have this. Okay, we'll be creating a table, create table users, and I will quickly check the what are the column names I have given. Name, description, created at. Okay, we'll be giving name as varchar 120. Description we'll be giving, and created underscore at, right? Yeah, this will be, I guess, timestamp. Let's say, oh, okay, I'm creating table users, so let me just quickly change the table name, that will be using items instead of users. Okay, we are good to go. Yeah, if I do slash dt, okay, items table is here. So let me just quickly run this node app.js. So currently I'm not running the container. This is our basic normal program which we run on the terminal. So okay, it is up, and if we go at insert data, so you will be seeing fail to insert data, column ID doesn't exist. Okay, we'll check what the issue is there. Okay, column ID, let me just check. Name, description, created at, insert into items, name description created at returning id. Okay, let's just drop the table, drop table items will be doing, and I will be just using again create table items. Id end will be giving, and after that this, why it is not getting copied. Yeah, let's check again whether it's inserting or not. Okay, this is down. Let me just make it up after.js. So these are the issues sometimes you face while building the project. Okay, that is fine. Now here you can see data inserted successfully. Okay, so if I will go at database and I will check select star from items, so you can see example is an example and created at this. Okay, so we will again, if I reload, then next entry will be created. So if I do again the same query here, let me just copy it. Okay, something happened. Okay, here you can see another insert has been done. Okay, so this is the basic project, very simple project, but here you will get to learn about the Docker network. So before that, what we'll be doing, we will be creating a network. So the very basic command to create a network is net docker network create and backend. Okay, already I have created a network with this name, so it will give me a response network with the name backend already exists. So you can create the same network, and then what you will need to do, you will need to stop the current Postgres which you are running. So currently I'm running this Postgres. I will just simply stop it, and then I will be running a different container with the same network. So that I will be writing as a hyphen hyphen name. Okay, yeah, here already I have here. So here you have to add this flag hyphen hyphen network and your network name, and this is the image name. So what we can do, I will be giving here the container name as a Postgres, what we can say, PostgresCon 3. Cool. Now if I do docker ps script pause, okay, this is the running container. So already volume and all everything we had added, so our data will not be lost if a new container comes in between. Okay, that's cool. So next we will be doing our docker file. So already I've created a docker file. So we'll be using node alpine image. We'll be copying everything and we'll run npm install there, and this is the command which we'll be using, node node app.js. Okay, and there's one file docker ignore. So in this I have added node model so that whenever we will build it, so we should not get any, which means node model should not get into your image, otherwise it will be a very heavy image then. Okay, so changes in app.js, what we'll be using instead of this localhost, here we'll be using the containers name. So in the containers, it in the same network you can communicate with the whole containers name as well. So here we have postcon 3. So if you will check, so here it is. uh, 1 minute, where it is that yeah, this one postcon 3. So we'll be using the same thing, host name as container name as the host name. So next let's build the project. Build hyphen t express, I will not use, I will use express 1. Okay, it is building. Okay, build is done. Next we'll run this project. Run hyphen f hyphen dit hyphen name. Okay, exp1 I will be giving here, and the port mapping which we do, that is I am mapping 3000, and the same network I am using as backend. Okay, so it is giving me some exp1 is already in use. Okay, let's do exp2, but something is happening. Let me check. ps hyphen a grep exp. So okay, so what we need to do, we need to just remove these containers. So I'm quickly removing. Docker rm is the command to remove the containers, as we already know. So docker rm, yeah, done. Okay, but still it's failing. Why? 3000 is already in use. Why in use? Because I'm running this. Okay, cool. But I will just remove exp2 here. Okay, and I will run it now. Yeah. So if I will do docker ps hyphen a grep exp, okay, it is running. So now if I will do this local host 3000 insert or 3000, it is up. Okay, even if you want to check logs, if any logs it is showing, so we can do docker logs and this id. So nothing is we are means printing, so that's why nothing is coming up here. So what we can do, we can check if we will insert, sorry, I had to do insert data. Okay, it is showing failed to insert data, get address info not found, post con2. Okay, why? We'll see. Docker ps hyphen a grep pos. Okay, we had used post con3, but there we had given post con2, that is the issue. So we'll quickly go into the app.js, but we can do one more thing. Instead of going app.js, sometimes it happens in real time as well. So what we will be doing, I will log in into the this express container, docker execute hyphen it, and let's take this. Okay, bin bash. Okay, we will be using sh10, yeah, ls if you do, and that is fine. Here app.js is there. So instead of postcon2, we'll be doing postcon3 here. Okay, and we'll check the process grep app. So one is running, we will be doing kill one, then again we'll be running node app.js, but okay, what we can do then, ps hyphen a grep express is there, we will simply stop the container. It will take some time to stop. Next we can again restart it. Okay, now we can check. Now you will see data inserted successfully. So if I will log in into my Postgres container, so I should be able to see the data. So we can do docker execute hyphen it slash bin bash. Okay, then we'll be doing psql hyphen u postgres hyphen d postgres, then we'll be doing slash dt, then I will doing select star from users. Okay, not users, items. Okay, third entry is done. Now I will do multiple times here. I'm reloading, just reloading. So we'll see what happens here. If I will do again the same query, what I get. Oh, cool, nice. So on every reload, there is an entry into the database. So in this way, our Docker deployment is working fine. Now, the next thing which I had told, we'll be using ping. So actually ping is not there, then you need to install it. So you need to do apt get install. Uh, something tools are there. I'm not sure what it is. Let me check. Okay, we'll be using here ping install Ubuntu. Okay, fine. Okay, we can do this iputils dash ping. Okay, unable to. Okay, let's just update it. Okay, it's updating. It will take some time. Let me log in into the another container as well. So I'll be doing docker ps-a grep express. So docker execute -it /bin /bash give sh and the ping. Okay, ping is here. Nice. So we'll try to install ping here as well. Okay, here also we have ping. That is nice. So we have both containers. We are inside both the containers. Next, let's open up a new terminal, and what we'll be doing, docker ps grep pos. Okay, and to check the ip we have a command docker inspect container id grep ip. So this is the ip which we have got here. Okay, so what I'll be doing, this is the ip of the container. Which container, but it is of Postgres one, right? Yeah, this is the Postgres one. So I will be doing uh, ping. Let me just exit and check it is which one. 99DA. It is which container, we'll see just quickly. Okay, 99DA is the uh, express one. Okay, C29, this is this one. So I will simply do ping, and I will do here docker ps-a grep express. So here we'll be doing docker inspect grep ip. So let's just copy this ip and ping this. So here you can see you are getting a response from that particular container, so you are on the same network, so that's why, that is the reason. So next is we'll be doing ping from express to postgres. So express is here. Okay, here it is too. Yeah, so in this way you can communicate with the containers between each other on the same network. So this was the overall project. So hopefully you learned something new, and your concept of Docker network also got cleared. If not, if then what next we have? The next we have, we'll be doing some more projects as well in this full series, and please share the course with other people, and feel free to learn anytime. So that's it guys for this video. See you in the next one. Thanks. Welcome everyone. Today we are going to learn how to deploy a PostgreSQL database. Okay, so this is a perfect whether you are developing locally or setting up a production environment. So it will help you in that. So by the end of this tutorial, you will know how to create a first of all persistent Docker volume. Okay, I will let you know why it is required. Docker volume. Next, you will be learning about how you can deploy a PostgreSQL and the configuration what are the configurations required to set up the database. Third is you will be connecting to database. Fourth, you'll be creating tables into that. And fifth, you will get to know about where your data is stored physically. Okay, so basically you will get to know about the data storage. Okay, so let's get started. So first we need to create a persistent volume to store our PostgreSQL data. So, but before that, let me just explain you a bit about the persistent volume. So what is the basic requirement is if our container is running, okay, it is the running stage. Okay, you created suppose 50 tables into your database and somehow something happens, your container stops. So in that case, you will not have this 50 tables in your hand. You will lose all the data. So that's why we need a persistent volume. What we'll be doing, we will be mounting this one data path to our host path. Okay, so to our host path, or you can say to our volume which we'll be creating. So even if the container stops, so what will happen? It will refer this host path and then your data will be safe in the host system. So this is the concept. And so now what we have to do, let's create a volume. So the command is docker volume create. Okay, already Postgres data is there, I guess. Okay, just I will give like this Postgres data. Okay, now do docker volume ls grep Postgres. So here you will see I created this one. So what I'll be doing, docker inspect to check where your data will be stored into the host system. So it is stored into the vol lib docker volumes Postgres data, the volume name, and then underscore data. This is the path where your data will be stored. Okay. So in this way we create the persistent volume. Okay. So now let's deploy our PostgreSQL container. We'll use the official PostgreSQL image. So for that, Docker pull Postgres latest. It will take just some time. And we'll use this image and connect it to our persistent volume. So what you will be doing, we'll be running docker run command. So okay, already I have this command. So I will just change something here. I will be changing the container name. I will give postcon and the parameters which you need to provide the environment variables, that is the Postgres user equal to Postgres, any user which you want, and the password you can give anything, and the date DB name, and the port I will be using 5432 host port as well, and the container port as well. And then the volume you can see here, I will be providing Postgres data. Okay. And after that, this is the path that Wally PostgreSQL data. This is a path where your data will be stored into the container. Okay. So what will happen? Everything will be in the sync. Okay. So even if new container comes, then it will refer to the same path and all the data will be there. So container is running. Let's check docker ps script pause. Okay. Let me just execute, means log into the container, and we'll be creating PSQL. We'll be login PSQL -u, username is Postgres -d, also Postgres. Okay, and here you will use this /dt or /dn command. This is the schema. I'll be creating two tables into this schema. Create table users and just id end. That's it. One column only I need. Then I will be using create table employee id end. That's it. Okay, if you do /dt, here you will be seeing two tables we have. Okay, so next thing what we have to do is I will just exit and I will show you where the data is exactly stored. So var lib PostgreSQL and the data, and if you do ls here, you will see these files are there. Okay, so next task is for us to check whether persistent is working or not. So what I'll be doing, I will just stop this container and remove it. Docker stop. Okay, and I will remove this container, and again I will run the docker run command, and I will check whether my data is there or not. So here you will see that we have got a different ID, and I will be using docker execute, and here only I can write the command psc equal -u postgres -d postgres. Okay, next check /dt. Okay, cool. Here you will see we have this employee users table, both are present. So in this way persistent volume works, and this is the database which we just containerized Postgres one. So in the next project we'll be using this database for our deploying application like front end, back end, these all things. So that's it guys for this video. See you in the next one. Thanks.
Hello everyone, welcome to another project, and in this class we are going to talk about how we can deploy a Angular project. Okay, so basically in this class we have a project which is developed in Angular, and it's a basic portfolio website. Okay, it will have some pages like home, about, and contact us projects. Like these pages are there. So we'll be deploying it. So let me tell you before the basic architecture how the project will be. So basically we will be having one front end. So that is in Angular, and we are having a back end Node.js which is used to handle the contact us page, and we have our DB, that is a Postgres. So already we have covered uh, things to deploy, like we have covered about the backend, that is Node.js. We have covered about the DB, and now today we'll be covering about the Angular. And then in the next class we'll be deploying all these three together, and we'll see how it works. We will be learning about the Docker Compose and all those things. Okay, so let's begin. So before deploying it, I will show you how the project looks like. So this is the structure. As you can see in the project for directory, I have front end, back end. This basic project you can avoid. I will just remove it. Okay. So I will show you the front end how it looks. So I will do ng serve, or you can see like in portfolio. Portfolio, it's a basic portfolio website. If you go in src and app, I have different components like home, about, projects, never, contact. Okay, I will simply do ng serve, so not server, ng serve. So this project basically Angular project, it starts at port 44200. So in container also we need to expose this port. So let's see how it looks if I do 4200. Okay, it will take some time, we'll just wait. Okay, here you can see this is a basic website. About is there, projects is there, and then contact is there. Okay, if I do write any message, then the data will be stored into the DB. So let me just tell you this flow. So whenever I submit the form, okay, this is a form, you can see it will send a request to my Node.js, that is a backend code, and it will send the request on /API/ something. I will show you, and then the data will be inserted into the DB. This is the basic flow. So if I will go here and I will start my backend, so I will go like backend, and here I will be doing node server.js, and I will open up another terminal, and I will do docker ps. Okay, here you can see Postgres, that is exited or what, docker ps. Okay, so I'll just restart this DB. Okay, so what I'll be doing, I'll be writing something here, Udemy user, then Udemy at g.com, and something. Hi, this is test. If I do send message, here you can see message sent successfully. If I want to verify, I will simply log into the DB, like docker execute -it, then this. Okay, I will do /dt, and I will just do select Start from contact messages. Just a second. Let's do again. Select start from contact messages. Okay, here you can see Udemy user, Udemy, the one which I added, and these are the fields. So in this way, this basic project is working. So now our task is to deploy the front end for now. Then in next class, we'll be deploying all these three together, and we will have the full 3D architecture deployment. Okay, let me just exit from here. I will just close it. Okay, and just come at the home. Okay, we are at the portfolio here. We'll be creating a Docker file. So we'll be using the image of Node.js. We can use Alpine or Lattice. Then we'll be creating a directory. Work.dir we can keep as app. And then we'll be copying everything. Then we'll be installing Angular CLI. So npm install -g at the rate Angular slash CLI. Then we're doing run npm install. Then we'll be exposing the port of 4200. Then the command will be running ng serve. Then we do -host and 0.0.0. It is basically your local host itself. So in this way, we write the Docker file for the Angular application. Okay, so let me check if anything is pending. I guess everything is done. Yeah. So we'll just save it and we'll build the project. Docker build -t portfolio image. Okay, so okay, it doesn't exist. We'll be using then latest we can use. Let's try again. Mm, okay, this also it's showing doesn't exist. What is the issue? Okay, the issue is we have written Node.js. We will be using Node, right? We can use Alpine. That's fine. Yeah. So now it is ready. So we'll wait for it to for completion. Then we will go for the next section. Okay, it is completed. So we will just do Docker images. Grab port. Okay, we have this portfolio image. So I'll be running this image. Docker run -dit -name. I will be using the container as pi cont. Then -p will be using the host port as 4201. And yeah, that's it. Docker run -dit -name we have defined -p. And we'll be assigning the image name, that is portfolio image. Okay, that's cool. If I do docker ps, then two containers should be running. Okay, only one is running. We'll check for this. Yeah. Okay, this one we'll see the logs. What happened? Unknown arguments. Host server. Okay, I guess I made some mistakes in the Docker file. So ng server we have given here. We have to give ng serve. Okay, we'll again build the image. That's fine. It will just take few seconds now because now it will take from the cache, as you can see, using cache. But if you don't want to use the cache, you can use the option hyphen hyphen no cache, like this. You can write hyphen 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 no cache. So this is a one way to avoid the cache in the Docker. So we'll wait. It will take just few seconds more. Okay, it's done. So we'll be again running the image. But before that, I will be removing the container that which I created. Yeah, that is fine. Now we'll be doing Docker run. Okay, let's do Docker PS. Okay, two containers are running. That's fine. So now what we can do, we can open up the browser and we can check. Okay, so here you can see the port number as 4201, which in our container is running. So here we can just go and see the contact section. I'll writing just u1, then u1 at g.com, and I will be writing some messages like u1. Okay, send message, it should work. So here you can see message sent successfully. Okay, so in this way we deploy the Angular application. So it was quite easy. So in the next project, that will be a good one. We'll be using Docker Compose, and everything will be integrating the DB, will be integrating the backend Node.js, and we'll be using this Angular frontend. So all these three together will be doing a project. So that's it for now, and let's see you in the next one. Thank you.
Hello everyone. So in this class we'll be learning about Docker Compose. So we'll be deploying the front end, back end, and the DB. All these together with the help of Docker Compose file. So basically in our previous classes we saw how we can deploy the front end, that is Angular application. Then we deployed Node.js. Then we deployed PostgreSDB. Okay, so we were using a Docker run command to deploy each and every container one by one. But now in this class, that will not be the case. We'll be using a Docker Compose file and we'll be writing each and every detail, and we'll be deploying all the containers at once. So, but before going further, let me just tell you how the structure will be. So basically, we will be having three containers. So this is when we can say front end. This one will be the back end, and the next we have DB. Okay, and it will all will be on the same network. So we'll be creating a network using the Docker network create command. Okay, so we'll be giving some name, and the network name we can give anything. And for DB, as we have already volumes, so that volume we'll be using, and ports and all will be deciding how we can do. So ports will be from host port and container port. We'll see how it works, and the flow will be like you will be opening your browser. Okay, you will go on localhost some ports like 42001, and it will open up your front end. Then front end we have a contact us page. There will go, then there will fill the details, and then request will go to the backend. Okay, then from backend we'll be calling the DB. So whatever entry you will be writing here, it will be inserted into the DB. This is the basic the flow. So on this we'll work on it. Okay, so let's start. For that, some changes we have done in our Node.js file, that is server.js, and for this server.js, and uh, yeah, there only we have changed. Uh, we have changed with the
service name of Docker Compose. Like in Docker Compose, whatever services we have, like the structure will be like services, and then we'll be having different services like front end, back end, DB, like this. So we'll having different services. So in if your container is on the same network, then you can use the service name. That in case of DB Postgres, we can use DB as a service name. Okay, so we'll be using this thing, and it will similarly act like whatever we write, like http colon localhost and some port like 5432 or something like that. So we'll be using, instead of local, we'll be using DB in host. Okay, so I will show you how everything will be working. Okay, so we can go Kali. Okay, so here in the front end we have a portfolio. Here we don't have any changes. The most important file here for us is this only. Here like localhost 3000 I have kept because we are accessing this from the browser, so we will not be using here the backend thing. Okay, and next we have this backend. We'll go in the backend, and here we have server.js. And in server.js, you can see in host I am using Postgres. I'm not using localhost or 127.0.0.1. So Postgres will be the basic the service name. Okay, so now I'll be creating the Docker Compose file. So in project 4 only I'll be creating. So we can create like vi docker compose.yml. So here the first thing which you write as the version. Okay, so that will be, I guess, current version which is going on is I guess 3.8. So I'll be using the same 3.8. So let me just do it. Okay, next we have is services. So we will write like this services, and then in services we have different services. So first I'll be using front end, and I have created an image with name front end. So I'll be writing image. So the image name I have created with the portfolio, and then we will define the ports. So ports will be my host port. I will be keeping as 42001, and the container port I will be giving as 4200. Then I have this depends on I will be giving like this. Depends on is used to like first if backend is not only up, then what is the use of using front end? So that's why we have used depends on, so that first backend should come up, then front end. And then we'll be using networks. So here I'll be using network as my network as name. We can give my name is portfolio portnet we can give, yeah. And next we will be doing the service as backend. Okay, in backend also we will give the information like image. So here image I'll be using as the backend. Okay, next the port I'll be using, ports I'll be using as 3000, same 3000. And same here I will be doing depends on. So here depends on will be on my DB. So that I'll be writing Postgres. Postgres is the service name. Next we can have our DB, or I'll be writing Postgres only. Postgres is my service name I'll be using. So in case of Postgres, I'm using everywhere the name is Postgres only. So image I already have Postgres. Then I have ports. Ports I will be using 5432, 5432. Okay, so I missed this. Yeah, here also. Okay, so 1 minute. Yeah, cool. It should be in the same line. Yeah.
The indentation should be proper. Okay, ports is done. Then we'll be doing depends on is not required. We'll be using environment here as we know we pass Postgres user like this. If we open our new terminal, and I will show you what else what we use to pass for the Postgres container. So if I do -dit hyphen name post something, so here you can see we use to pass Postgres user, password, Postgres DB, and even volume. So that we'll be doing now. So environment we can use this Postgres underscore user colon. I'll be writing here Postgres. Then here we have Postgres underscore password colon Postgres. Then we have Postgres underscore db colon. I have then Postgres. Okay, and the network I will be using here the same which we are using above network. So networks will be the what is there in backend. Okay, sorry, I missed networks in my backend, so I'll be writing here also networks, that is portnet. Nice. Here also we'll be writing portnet. Cool. Okay, so after that next we have the volume. So here we are using volumes also, right? So we'll be using volumes. So volumes, we know I'm using this Postgres data. Like if I do here docker volume ls grep Postgres, so I'm using this one. Okay, so doc volumes Postgres data, then we need to give the internal path of the container also, that is var lib Postgres SQL, and then we have data. Okay, these are things we defined here, and the same thing we need to define here also. Volumes, just name will be doing Postgres, we're writing Postgres data colon, and then we have external true. Okay, the same network will be defining here. Networks, my network is port net. Cool. Okay, so what else we need to do? So we need to create a network. We can use docker network create. We'll be using portnet. Okay, so docker network has been created, and already the volume we have, if you'll see volume ls Postgres, and if you inspect it, docker inspect. Okay, so here you can see volume docker volume, say it is here, it is present. Okay, so we'll just save it, and we have a command for a docker compose up -d. So here you can see volumes to Postgres data addition for external is not allowed. Okay, we'll check what we can do here. We miss the spelling is incorrect. Let's do again. Okay, here you can see it is creating for me the contents. If I do docker ps, so all are 3 seconds up, 4 seconds by 4 seconds, 1 second, like that. Okay, so everything is up. So with the help of docker compose, we can combine all the containers at once and use it. So okay, we'll verify once. Okay, so we'll be doing localhost 42001, I guess. Yeah. Okay, portfolio is up. You can say the same website is projects, and then I'll be using here writing something like project 4. I'll be writing project 4 proj@test.com project, send message, and here you can see message sent successfully. Okay, if you want to check logs or something, you can give a command docker logs here. Nothing is there. Okay, everything is fine. And now what we have to do, we will be logging into this container, that is a Postgres container. Docker execute, okay, the same command we'll be using, just I will rename the Postgres container, and I will be doing /dd, and I will be doing select star from contact messages. Yeah, okay, so here you can see project for project at test project is created here. Okay, so in this way we can make up different containers all together. Okay, so here we use the docker compose file, and we also learned about this, how it works, how is the internal working of these things. So also, if you want to go in more details, we can have, if you do docker ps, and if you do docker inspect, this one, this is which one, this is front end one. So here you can see everything, you can see the IP address for this which has been assigned. So if I will log in into the first and try to ping, that also I can do. So suppose if I want to I will log in this front end, and in another tab I will be logging to backend. So here I'll be doing docker execute -it /bin/sh. Okay, so here if I do command host name -i, sorry, host name -i, it will give me the IP address. This is my backend IP. I'll try to ping it from this so that I can just whether I'm getting reply or not. So here you can see I'm getting a reply from that server. So it means it's all on the same network. We are able to connect to each other. We are able to talk to each other. These two containers are able to communicate with each other. So in this way everything works. So that's all for today's class, and see you in the next one with different projects. So thank you guys.
Hey guys, this is Ayush, and from today we are going to start the Kubernetes series. So this is the very first video of our Kubernetes series. So today in this particular video we'll be discussing about the introduction part of the Kubernetes. Like we will be discussing some of the things like what is Kubernetes, why it is used, and some like from where it has came, like all the things we are going to cover in this particular video. So let's start the video. So basically here you can see the title which I have is Introduction to Kubernetes. So actually I have already written some of the points for you to understand it better. So if you will go down, and here you will see some of the points I have already mentioned here, like Kubernetes is nothing but the open source container management or the orchestration tool. So we'll discuss it, what is this container management, later on this video. And it is also developed by the Google, like the company which everyone knows, Google, and it's written in the language called the Golang. So it is one of the language which is used, or which has been used to create this particular thing, that Kubernetes, the tool. And also it is used to manage the containerized application. So if you are watching this video, so it, like you might be aware of the containers, what are the containers, what is Docker, how containers is made, everything, like it, like I suppose you know it. If also you don't know, like we will cover it in this video. Okay, and also it is referred as the K8s. Why it is referred at K8? So this is the thing, like you will see between K and S there are the 8 letters. So if you will count that 1 2 3 4 5 6 7 8, so there are 8 letters between K and S. So that is the reason behind it Kubernetes is referred as K8. So this is one of the reason. So this is the basic overview about the Kubernetes. Okay. So let's move forward, and we'll be discussing about the what is this container management and the orchestration tool. Okay. So actually, Kubernetes is also one of the container management and the orchestration tool. So it is also one kind of tool which is used to manage the containerized application. Like what it will manage? It will basically it will that deploying that container, scaling, managing, and all those things. It's done by these kind of tools like the Kubernetes. So like in market we have also some of the many different tools we have, like we have Kubernetes as well, we have Docker Swarm, we have Apache, we have OpenShift as well. So there are many tools there in market, but Kubernetes is one of the very like famous tool which you can say like in like by the way it's developed by the Google, that's why it's a very fascinating product. Okay, in this DevOps industry. So the point here is the whatever the container is created by the developer. So to manage those containers or those images, we require the Kubernetes. Okay. So this is the reason behind whole thing, like why it came in role. So the answer is simple. It came in role to manage the containerized applications. Later we will see like what is the whole like how it manages, what are the concepts which is required. Everything we'll cover in this particular video. Okay, so let's move forward. If you will go, I have prepared one chart. Here you will see what Kubernetes is. So Kubernetes is nothing but the container management tool. And what container management tool does, it manages the containerized application, and containerized application where it is available, like the whatever the application which is available on platform like the Docker. Like on the Docker, what happens? Many platforms, sorry, many containers are available there, or the images we say Docker images are present there. So from there, you can access that image and use it in your machine. So if you don't know the concept of the Docker, so let me tell you first about it. What Docker is simply. So what happens whenever a developer, suppose this is a project, okay, a developer is there who creates a project in Python version 2.3, okay, and this project is on machine, sorry, this project is on machine A, and now developer wants to share his project to some other team members, or suppose some other team like testing team. Now the project is going into the testing. So at that time, uh, in the testing machine, in the testing team, their computer is B and their Python version is 2.9, and here the project comes. So in this, what will happen? In this, the project will not run because the project is made on the version of 2.3. So it might be case like some dependencies may be deprecated in the version of 2.9. So it might case like the project will not work on the tester's machine. That's why Docker came in role to solve the problem, like the code which you might have listened, like this code works on my machine but it doesn't work on your machine. So basically to solve this problem, like code works on my machine but not on your, that's why the Docker came in the role. I hope you got it. The point what I'm trying to tell you here. So project 2.3a and 2.9b is there. Okay. So what will happen if we create one thing like the Docker? Suppose I just create one. This is suppose one Docker is Docker container I have created, like the developer created, and in that the version is same 2.3. And what will happen? The second team member, the B, he will also access the same container and he will also like use the same container. Okay, so in that case both of the team member is using the project with the same configuration. So basically what happens whenever a container is created, so in that case similarly the thing what happens is it basically the whatever whoever is the developer what is does it just what we say Add all the dependencies. Okay, dependencies you can tell, or you can say all the source codes, whatever the required data or required libraries. Okay, whatever the libraries is required to run the project, everything will be present in that Docker container. So if someone else will run that container, or will run that Docker image, so obviously it will run because it has all the configuration already installed to run it. Okay, I hope this point is clear to you about the Docker. What is a Docker? Okay, so now let me tell you about the containers, like not containers, about the Kubernetes, like how it helps the Kubernetes. So what happens the case, like normally when you will be learning, so you will simply create only one container or two containers max to max. But what happens in the real time basis, the thing is what happens, we create different number of containers. Okay, if you I want to go down, and here is one container. Okay, and here is another container, and here is another container, here is another container. Suppose I have so many containers for a single project. Okay, so let me just create one more like this. Okay, it's fine. Suppose this is the project which have like project. Okay, I have one project here, or one application, you can say. Instead of project, it's better to call it application. One application is there, and I have so many containers here. Like these are the containers which you can think of. Okay, so these containers are already there, and what Kubernetes will do, Kubernetes will like it will help in deploying all these containers, scheduling, scaling these containers locally, or locally, or it can be on cloud. Okay, basically we not we scale in cloud, not locally. Sorry for that. So Kubernetes, what Kubernetes will do, it will basically do deployment of these containers. It will schedule, and it will scaling, like help in scaling everything, like required, like monitoring is also there. Okay, so what Kubernetes will do, Kubernetes will take care of all those things of a container. Okay, of these number of containers. So like later in the videos we will learn about pods are one of the thing which is important to know. So pods is nothing but in a one pod we have with so many containers, one storage volume we have. So like we will discuss these things later, like in the upcoming videos. So what is the pods and what are the other concepts? So here the main concept of the Kubernetes is to maintain the deployment of the containers, and how we can scale these. So basically to manage the containerized application, that is the simple concept of Kubernetes. Okay, so in this case, suppose we I have already told you, like so many containers if you have, so what we will do, we will basically with the help of Kubernetes, what will happen. So if I take this image of Kubernetes, and if I just put it in middle of that, sorry, huh. So if I just put it here in that, so and these are the some containers. So what it just shows, so it shows us all those things management of the containerized application. If you go upon the chart here, so here you can see manages containerized application. So how it manages, so with help like this it manages, like in the in deploying, scheduling, scaling, and also load balancing is also one of the important thing. Like load balancing is also the Kubernetes also used to manage the loads between the containers and all those things. Okay, so this is the overview of the introduction to Kubernetes. I hope you liked it, and I hope you have cleared the concept of Kubernetes and as well as the Docker. So today we will stop here, and thank you for watching. I'll meet you in the next video. Thank you so much. Now in this class we will look at the basic architecture of Kubernetes part 1. So this is the part 1 of this architecture video, and in this we will be covering about the overview of the Kubernetes components, the basic architecture, and what is the master, worker, node, pods and cluster. These things which we are going to cover in this particular video. So before starting this, I want to ask you one question. Like, if you worked in a team, so in a team which we have some of the components, like we get one manager, some team members, and the manager is responsible for managing his whole team. So, on the same basis, on the same criteria, the architecture also works, that Kubernetes architecture. So, here I have one image for you guys. So here you will see the manager is there, and here some three persons are there. So manager and all person is making up one team. Okay, so manager is responsible for managing and coordinating with these person or these team members. So in a similar case with the Kubernetes architecture as well, the manager is get replaced with the master node and the persons is get replaced with the worker nodes. Okay, so these three are the worker nodes and the whole thing makes up as the cluster. Okay, so this is the cluster which is made up with the master node and the worker nodes, and in the worker node we have these things. I will describe it with you what are all those things. Okay, so I hope it is clear to you what is the master node and what is the worker nodes. Okay, so we will go deep down into this about the worker nodes and all the cluster. So this whole thing is called as the cluster. I hope it is clear. So here I have some notes on the cluster, what is the cluster and all those things. So here you can see the first point which we are covering is the master node is responsible for managing the cluster, and also whenever we deploy the Kubernetes then we get a cluster. Okay, it's correct. And what is a cluster? If someone asks you what is a cluster, so cluster is nothing but the set of machines. Okay, here you can see that is called nodes. So these are the nodes. This is the node 1, this is node 2, this is node 3. Okay, and if you go further, here you can see there can be more than one master node in a cluster to provide a cluster with failover and high availability. So here you can see like here we have only provided one master node. Okay, but in the real life scenario we can have multiple master nodes in a cluster. So because if one cluster fails or one particular machine or particular node fails, then other can be used. So it just useful for the application or whatever the container, whatever the cluster is there, it should work always. That's why the high availability should be there. And also here you can see the multiple cluster in Kubernetes architecture. It is also possible, like multiple cluster is also possible in the Kubernetes architecture. We can have cluster 1, cluster 2, cluster 3, and also in clusters we can have multiple master nodes and all those things. Okay, so this is the some of the basic information about the cluster, and also now we will deep down into these pods. Okay, so here you will see some of the points on nodes and pods. So here you will see what is a node. So a node can be a physical machine, a virtual machine, or virtual machine on the cloud which we run on, like EC2 instance, like VM, Windows VM, Linux VM on AWS or Azure portal, which we do. So it can be anything, like a node can be anything, and each node in Kubernetes contain one or more pods. So now let me describe you these things. This is the pod. So what is pod? So pod is nothing but uh, like in each the worker node or in each node the pod is there. Like here you can see uh, each pod contains one or more containers, and containers are responsible for running the actual containerized application code, while pods provide a logical host for those containers and manage their shared resources such as networking and storage. So actually, what happens, like in our previous class we have talked about, like one application can have the multiple containers. Okay, so what happens, like when we do deployment and all, so while in worker node we can have the multiple pod. Okay, So in multiple pods, and in each pod there can be the multiple containers, and also here with containers we get one storage space as well. So this there is a big concept about this all pod thing, like they share the same storage, and also the all the containers are there, whatever the containers are there, they share the same storage as well. Here we get one volume as well. So they share the same storage, and also the same network is being shared with within each each nodes. There is, suppose there is one pod. So if you will look at here, so here we have three pods. Pod 1 is there, pod 2 is there, pod 3 is there. So everyone will have the IP like 10.0.0.1, 10.0.0.2, 10.0.0.3. So like they work on the same network as well. So this is the like basic architecture of the Kubernetes. Okay. In our next class, we will look into the further thing, like what are the like complex architecture things inside this Kubernetes architecture class. So I hope you got it. If you have any query, you can ask us. So that's all for today's, and I'll meet you in the next video. Thank you for watching. Hey, now in this class we will look into the architecture of the Kubernetes part 2. Okay, so basically in this class we will go deep down into the architecture, and also we have already covered the first part of the architecture in our previous class, in which we had discussed about the master node and the worker node. So now we will just go a little bit deep down into that, and we will see what we will do today. So here are some of the topics which we are going to cover. So basically the first topic which we are going to cover is the components of the master node, and the second one is which we have the worker node. So I hope you are aware of the master node. Okay, so master node is basically used to manage the cluster and doing all this stuffs. Okay, so let's start with the first topic. So here you can see the one image which you have is the master node. It represents the API server, scheduler, controller, and this is etcd. So you might be thinking, what is these all things? Okay, so basically the API server, scheduler, controller, and this etcd is nothing but the components of the master node. Okay, so master node is not the single thing. Like inside that we have four components. So about all these four components which we will discuss in this particular class. So let's start with the very first one, that is, and the very important one which we have is the API server. So what is a API server? So API server is nothing but the very first component or the very important component of the master node. Without that, you will be not be able to access the cluster, that the actual Kubernetes cluster. If you want to access the cluster from the outside using your machine, then you will go through the API server. Okay, why? Because API server provides the interface. Okay, it just provides you the interface. Okay, like it may be like a UI interface. Okay, or using command line tool also you can do. You can access the Kubernetes cluster. So here are some of the points which are mentioned. You can see like it is the main gateway to access the Kubernetes cluster, and also it is a central component of the Kubernetes control plane. So now you might be thinking, what is this control plane? So it's nothing but it just represents your master node. It means the control plane is simply means all the set of components which are used to manage the cluster. So obviously master node will be the one. Okay. And the third point which we have, you can see here, the exposing APIs which allow user to interact with the Kubernetes cluster. So it simply means like making the Kubernetes API server accessible to other components such as client tools or web UIs. Okay, so exposing API is just that simple. Okay, it means that. And the tool which we use to access is kubectl or web UIs. Okay, it can be used to interact with the API server, and it is also responsible for validating the request. What does this line refers to? It simply means like whenever one client will request something from the API server. So it will first validate that request, whether that request is valid or not. Okay. So after validating the request, that request gets approved, and then the client should be able to access that thing or do whatever operation they want to do. Okay. So this is about the API server. I hope you got it. And then next, moving forward, we have another one is scheduler. Okay, so here you can see the scheduler. Scheduler is nothing but, as the name suggests, here you can see a scheduler is nothing but which is used to schedule the pods. Okay, so basically what happens, Like here you can see the first point, like responsible for scheduling pods or nodes. What does it mean? It simply means like whenever a new pod is created in Kubernetes, so what happens at that time? A scheduler selects a node for the pod to run on. Okay. So what will happen whenever a new project sorry what whenever a new pod is created, okay, when a new pod is created, and then after that what will happen, like it is not like randomly going and work on some particular nodes. So like you have seen in our previous class, here we have discussed like in the worker node we have pods, and in pods we have containers. Okay, so here it's removed actually. So here we have suppose containers. Okay, so what happens, like scheduler, what it does, the role of that is it just checks the what is the requirement of the pod and what are the specification of that pod, and then it decides on which container that pod should run. So that is the main work of that scheduler. Okay, I hope you got it. And also like some of the points is there, like the scheduler obtains the information from the etcd via the API server. So whatever the information should be there about the specification and the configuration, they access it from the etcd. Okay, and moving forward, we have the control manager. So control manager is nothing but, as the name suggests, you can see it just controls the or manages the cluster. It means monitoring happens there actually. So in that we have the kube control manager, which is responsible to inform the node. Like suppose in the cluster, if some node fails, so what should they do? The kube controller just sends the signal to the master node, and then whatever the action should be done, it is performed. Okay, so in Kube Control Manager also we have four controllers. We have like node, replication, service, and endpoint controllers. So these controllers actually work in the work not separately, they work together. Okay, so the node container, all these four containers work together, it's a single unit. So here are the some of the points, like node control what it does. So node control is basically used to monitor the nodes. Suppose if any node fails, then it just sends the report to the master node. And the replication controller is this maintain the current replica count. It means like maintain the current replica count. It means, so the thing is like what happens whenever user creates a pod, or whenever they deploy one pod with a specified number of replicas. So at that time what happens, the replication control ensures that this desired number of replicas is always maintained. Okay, suppose you are a user and you are going to deploy one pod, and at that time you also mention that that number of replicas should be there. Suppose you are deployment one pod and you are giving it like three replicas should be there of that pod. Okay, so in that case what should happen, if that replica should goes down, like suppose one fails, then replica remains two. So then that replication controller came into the role. It then again try to restart that pod and that replica, and then it maintains. Okay, and the service control is nothing but it just check whether all the services are properly configured or not, and the endpoint control is just to make sure all the endpoints should be accessible and it should be working. So this is about the control manager. And the last one which we have is the etcd or etcad. You can pronounce anything whatever you want. So it's nothing but the key value database. It is basically just like a log, like whatever the event happens in the cluster, like suppose one pod fails, and then one pod starts, or the node fails, node starts, node created, pod created, whatever the thing happens inside the cluster, it is just recorded into this etcd database, and it's actually a key value pair database. Okay, and it can only directly accessed by the API server. Okay, okay, so this one is the whole thing about the master node, components of the master node. Now moving forward, we have the worker node. So in the worker node also we have some what we see in worker node also we have some, sorry, I did something, I guess. Wait. So in worker node we have kubelet and kubeproxy. So these two exist. So we will look into it how this thing actually works. Okay, so kubelet is nothing but like it runs on each worker node. Like this is one particular worker node. Okay, so that kubelet runs on every worker node. Similarly, like the pod which is there on the worker node, in the same thing, kubelet also works on the every worker node, and it is basically used to manage the state of the pods. Okay, pods, running pods. Okay, like whether it fails or whether something happens to the pod, it just reports to the master node. Okay, so basically how does this thing work? So it basically works based on this pod specification. Like it is nothing but it is defined in the JSON or YML file, and inside that we get some parameters, like we get the metadata specification and the state. These fields are present inside that JSON or YML file, and based upon that, kubelet decides what to do. Okay, so and also it makes sure whether containers with whatever the container which are running inside the pods. Like here you can see I have one container. Just suppose you think it like as the container, and this is one pod. So like kubelet makes sure like every container should be running always. And we have kubeproxy. So kubeproxy is nothing but it is responsible for managing the networking aspect of cluster and the network configuration and the rules. So suppose networking things like IP addresses, DNS, all those things is managed by the kubeproxy. And the last one which we have is the container runtime. So container runtime is nothing but the software which is responsible for running the container. So actually Kubernetes does not provide the some direct way to run the containerized application. So that's why this container runtime came in the role. So this is basically nothing but the Docker. The Docker is the most famous and the most preferred and the most used containerized app software which we used. Okay, so there will be Docker. Okay, so this is all the things. I hope it is clear, like all the components of the worker node and the this one master node. Okay, so I hope you got it everything whatever we have discussed. If you have any question, you can ask us. So we will stop here, and I'll meet you in the next video. Thank you for watching. Now in this class we will talk about the Minikube and the kubectl. So these two tools are very important for the Kubernetes industry and inside this Kubernetes industry. So before starting the introduction of the Minikube, let me tell you about some idea about what exactly happens in the production environment or in the real world. So in the real world, there will be many master nodes and the many worker nodes. Just like here you can see in the picture, we have two master nodes and we have different worker nodes, like three worker nodes we have currently in this scenario. Okay, but it can be more and it can be less as well, but not it will not be easier for us to just create one cluster like this kind of. Suppose like the thing is, the node here refers to what? The node here basically refers to the virtual machine or the physical machine. So if you are learning Kubernetes, for you it's not possible to create those kind of to create the virtual machines inside the cloud in the instances like Amazon EC2 instance, or if you will use Azure, then there is virtual machine. So for you it's not possible to do all those things and create one cluster and everything. Okay, so that's why for the testing purpose and the learning purpose, Minikube came in the role. So what is a Minikube? Minikube is nothing but a single node cluster. Okay, here you can see I have written the definition for you. It's a one node cluster where the master process and worker process both will work on a single machine. So here the single machine means on your particular system. Suppose if you're learning on your Windows PC, then there will be you will install the Minikube and then you are good to go to learn about the Kubernetes. Okay, so here in the Minikube we are getting this master process, worker process, and also one benefit is that you get Docker pre-installed with that. Okay, so when you will install Minikube, then you will get Docker pre-installed with that. Okay, so also the thing is for using the Minikube, you should have the virtualization enabled. Okay, it's compulsory to work virtualization should be enabled. Okay, and also let's see the how actually it works. So suppose this is your host OS can be your Mac or Windows or the Linux. Okay, and then in that there will be VM, and after that there will be the Minikube. Okay, on that we will install the Minikube. Okay, so this is the overall idea about the Minikube. Okay, so and now let's see about the kubectl. So kubectl, as you are aware, it's nothing but the one of the command line tool which is used to manage the cluster. Okay, so this is the like basic definition of the kubectl. So in our upcoming class we will install the Minikube and the all those kubectl in different OS. Okay, so I hope you got it. If you have any query, you can ask us. Thanks. So that's it for today, and I'll meet you in the next video. Thank you for watching. Hey, now in this class we will see how we can install the Minikube and kubectl in the Ubuntu machine. So here I have written all these steps which are required to install the Minikube and kubectl. So before installing the Minikube, you should have Docker installed already. Okay. Otherwise, if you have not installed Docker, so you can follow the documentation and you can install it easily. And also like we are why we are using Docker here, because like Docker is easy to use and easy to like Minikube will work easily with the help of Docker when we will use the Docker as a driver. Okay, so also you can use VirtualBox, but there is a little bit of complications and all. That's why we are not using VirtualBox here, because we are running the Ubuntu machine in VirtualBox itself, so that will be very complex process. So that's why we are going with the Docker. So let's start with the installation. So here what you can do, you can just search for the Docker install in Ubuntu. Okay, and you will get here on the official documentation of the Docker. From here you can just follow. Like if you have already installed the Docker, then you can just copy up this command and you are just good to go. So I just demonstrate you. Actually I have already installed Docker, so let's do it. And then you can do just sudo apt get update. Then we have this one. You just have to copy and paste thing, that's it, and then you can install Docker easily. Okay, done. Next you have to do this gpg key. Okay, next this line you have to do curl command. Okay, wait a minute. Yeah. Okay, here actually it's asking me to overwrite, so actually we have already installed, so that's why it's showing. You can just put it yes, but in your case it will not ask you. And next what we have to do, we have to give the certain permission for that file, so you can just give it using this command. Next you have to use this command to set up the repository. Okay, done. Next what we have to do, we have to update, so we can do it using sudo apt get update. And then you have to install the Docker engine, so that's one is also important step. You can just do like this, done. And next we have to nothing, we just have to run this hello world command to check whether Docker installed or not. So here you can see Docker installed successfully, that's why you can just use the command Docker and check. So here you can see we are getting some of the information about what commands you will need to use. So just clear the screen. So with that we finally installed Docker successfully. Next, moving forward, we have Minikube and kubectl installation. So for the Minikube, sorry, here there is a mistake. Like we have written VirtualBox, but here we need to write the sorry, what we have to write, Docker. You can write like this with Docker setup. Move on the installation. Okay, installing Minikube on your Ubuntu system. So what we need to do, first of all, you will need to download the latest Minikube binary by using this wget command. So you can just copy up this command. I can provide these in the comment or description section. Okay, just copy it and you can just paste it here, and it will install sorry, it will download this file Minikube Linux AMD64. So actually I have already installed it, Minikube, and also you can, like I will demonstrate you how you can do it. Okay, so it will take some time to download that file. Just let's wait and let's move forward. What we have to do next, what we have to do, you have to just copy this file to this directory user local bin Minikube. Okay, so what for that, what command you have to use, sudo cp. Cp is the command to copy, and then the file name and the location. So just copy it, and next you can just do that one, and you're good to go. Okay. And next what we have to do, we have to give the certain permission to that file. So we can do it like this: sudo chmod 755, done. Okay, you can check that as well. We will go in that directory user local bin and ls hyphen l. We let me just increase the size and let me just clear the screen. ls hyphen l, if we do, here you can see this mini cube. Okay, and it has the rewrite permission. Okay, this is the execute permission. Okay, fine, cool. So that part is done. Let's move forward. What we have to do, you have to check the version of that mini cube. So if it comes, then it means you have successfully installed the mini cube. So here you can see its version is showing this 1.3.30.1. Okay, you can just ignore this. This is just a warning, you have to just ignore it. Moving forward, we have to what we have to install the kubectl. So for kubectl as well, also we will follow the same thing. We will just copy all those things, and then you have to just install the kubectl as well. Let me just come up on the home. Okay, done. So it will just fetch all those things whatever it's required. And next what you have to do, install the kubectl using this command sudo install, and then you can use the kubectl easily. Okay, here you can go. And now let's check for the kubectl version. There also you can see it's showing the all those things like version 5.0.1. Okay, so here it's showing because we have not started the mini cube right now, so that's why it's showing me this error. Let me just close it. So finally we have installed the kubectl and mini cube. Okay, so let's see some of the things. Like we will just start the mini cube using the driver. You need to provide the driver what we have to use. So driver will be equal to docker. Here you can see pulling base media starting existing docker container. So actually I had already made one container. So what we can do, we can just I will just delete those nodes. Okay, so it will delete. It will take some time, and then we will again create. Let's clear the screen, and we will just hit enter. So it will create. So keep in mind you should have two CPUs enabled, like in the system setting of your what we say, when you will go in the settings, and here you can see in the system, you can see in the processor tab you should have more than two CPUs, like three CPUs. Okay, so these things you should keep in mind. Okay, so it's creating. Let's see. It doesn't take much time, like it's first time. In your case also it can take much time. Okay, so here you can see kubectl is now configured to use minikube cluster and default namespace by default. Okay, so it means like we can use kubectl now. Okay, so if we will check for the status, so you can check the status with this command status. So you can see all those things are running. So in this way we finally install the minikube and the kubectl. So today we'll stop here, and in the next class we will see some of the commands. Okay, so that's it for today. I'll meet you in the next class. Thank you for watching.
Hey, and now in this class we will see about the minikube and kubectl commands. So I hope you are aware of what is minikube and what is kubectl. We have already discussed on these two topics in our previous classes. So let's start this particular class. Here I have the command example and the description. So we have so many commands. So we will see some of the commands in this today's session. So without wasting time, let's begin. Okay. So I have my Ubuntu machine running here. You can just open up the terminal with the shortcut that is Control Alt T. Let me just increase the size so that it will be visible to you. Okay, I hope that much is fine. Okay, so now the very first command which we see is the minikube start. Okay, so what does this basically command does? So as you are aware of what is minikube, minikube is the one node cluster which is having the master and the worker node both included in the one. Okay, so basically it will start the cluster. Okay, so when you will do the minikube start, it will take some time and then it will start. If you are running it the first time, okay, then it's fine. Actually, I'm also running it for the first time, so it takes usually some of the time. Okay, so we will wait for it for the completion. Okay, so till then let's see some of the commands, okay, which we have here. So here you can see with the first command that we have is the minikube start. Here you can read the description, like what it does. It starts the local Kubernetes cluster using the minikube, like we had already installed it. And then using the stop, it stops the minikube. Then status, it will display the status of that particular cluster, and then delete and all everything. Okay, so let's see. Here you can see we have cluster creator and minikube has been started. Okay, so here we can see about the further commands. Let's see if we do minikube status now here. Why it's not running? Minikube status. Okay. So here you can see the type is control plane, the host is running, kubelet is running, API server is running, kube config configured. Okay. So here you can just see some of the terms like API server, kubelet. Okay, all these terms like what you know about the what API server is now. Like we have already discussed it. Like if we use API server to communicate with the cluster. Okay, so here you can see using the minikube status command, you can check the status of the cluster, what's the current status. If you will do minikube stop, so it will just stop the cluster if I do it. So let's see what it does. Here you can see powering off the minikube. And also if you look at the table here, like we have delete, so it will delete the cluster. Okay, then we have IP, it will display the IP and SSH. Okay, so let's do all those things. So here you can see minikube is now stopped. If you will check for the status now, let's see what it shows. So here you can see everything is stopped now. So again, to start the cluster, what you can do, you can just enter the command like minikube start. It will again restart the cluster. Okay, like now it will not create the cluster, it will just restart the whatever the cluster which we had created just now with that command. Like this I was running first time, that's why it was creating the docker container and everything, like CPUs to memory, this much is required, all those things. Okay, so here you can see now it's just restarting existing docker container for minikube. Okay, so here you can see it's done now. Now if you will check the status, so you will get it's running perfectly fine, everything is running. Okay, now moving forward, let's check the minikube IP command. Okay, so it displays the IP of that particular cluster. Like we use this IP for using some of the services like which we look in this particular class and further. Okay, so next we have is the let me check. Minikube SSH is there and delete is there, so we will not use delete right now. Till then, let me show you SSH. So SSH is basically used to, it will connect to the virtual machine of that like minikube. Like whenever you install the minikube in your PC or in your Ubuntu machine, so at that time what happens, one VM is also created in that minikube. So with minikube SSH you can connect to that particular VM. So here you can write any Linux command which we use. Like here you can see who am I. So here you can see it says Docker. If you do like if you want to create some file like cat desktop tst, this is a test file. So it will, if you do ls, so here you can see the file has been created. Okay, you can read file as well. So in this way you can use the Docker. Okay, Docker like minikube SSH. So to exit, you can just write the exit command and you will just log off. Okay, so you can use this minikube SSH also to connect to the Docker VM. Okay, or actually it is used for the debugging and testing purpose as okay. So moving forward, we have now we have covered all this minikube commands. Let me move forward in the kubectl. Okay, so what is kubectl? Like we know that kubectl is the command line tool that we use to communicate with the cluster. Okay, so you can use the command like kubectl version. Okay, sorry, what it says. Command kubectl from snap kubectl snap info forward is the version. Okay, let me just check again. Just kubectl. Okay, fine. It's there. It's running. I think there was some mistake in the command. Okay, version. Okay, leave it. You can use kubectl to get the cluster info using this command. So here you can see you can get the cluster info. Whatever the cluster is running, you can get the info. And also the important part here is that for the running of the kubectl, your minikube should also run. It's not like your minikube is not running and then you are trying to run this kubectl command. So in that case it will not work. Okay, we will check that. If I stop the minikube, okay, it's stopping. And okay, let's wait. Okay, now when you will try kubectl cluster info, so in that case, you can see you are getting so much of error, like the connection to the server was refused and all those things. So that's why we should have Minikube in the background. Okay, so Minikube is started again. Okay, so Minikube has been started here, you can see, and now we can use kubectl again. So now let's see the table and we will do the we will run those particular commands. So here you can see kubectl get pods. What it does, it retrieves information about Kubernetes resources like pods, deployments, and services. Okay, so here you can see many things we have. Okay, also we have this create command. Okay, so it just creates the new deployment for Nginx web server. So what we will do, we will do this one. So how we can do it? So for that we have to just this clear the screen and let's run the command like kubectl create, and then we have the what we want to create, what service we want to create, deployment, and then we can just write the name, like we can write the deployment name as the nginx and the image which we want to use, like we want to image as nginx. So here if you are aware of the docker, then that time like that will be very helpful because the here image refers to that the docker hub images. Okay, so whatever the images you create and whatever the images you want to upload to the docker hub, and if you want to use those images, then you can use it from this, like using this command. Okay, so let's hit enter and here you can see we have this nginx created. If you will see for the kubectl get deployment, so here you can see we have nginx, it's not ready yet. Okay, so it's not ready yet. And also we can check for the kubectl get pods. So here you can see one container has been created. Okay, container creating, like it's creating. So what happens whenever you are deploying any kind of resource, like any kind of whatever resources. Okay, so at that time what is basically is happening in the background, like we have learned about the kubernetes architecture, like we have the pods, and inside pods we have container running, and some so many things like replicas is created, and that replicas is maintained by that the managers. Okay, so basically what happening is here the same thing is here, like when you are doing the deployment and pods is creating and the replica is also creating. So here when you use it by default without providing the replica, okay, so replica in the command. So what happens for that time, there basically only one replica is created. Okay, but when if you will provide hyphen hyphen replica is equal to whatever the number, then at that time what will happen, that particular number of replicas will be created. So this is the basic overview of this command. Okay, so let me again check. So here you can see the pod is running, and you can check for deployment also, it's also ready. So now what we can do, we can just expose this deployment as a service. So what does it mean? So basically we want to use this now Nginx servers, we want to use this Nginx server. How you do it? So for that also we have this kubectl expose. It's like we have this in the table. You can check. Here you can see kubectl expose deployment nginx type equal to node port. So here you can see what it does, creates a new node port service for a deployment named nginx. So basically the node port service, it simply means like that exposes the ports of the deployment to the specified ports. Okay, so we will define some of the port number, like here 80 is provided, but basically what happens, like whenever you try to get the URL, at that time the cluster basically defines their port between the 13,000 to some 32k thousand ports number. Okay, so this is the basic thing. So let's just run this command, and then we will be able to use the Nginx servers from our web browser. So how we can do it? Expose deployment, and then we need to provide the name of the deployment. The name of the deployment we have nginx. Okay, and then the type equal to node port. If we don't provide the port number, then also it's fine, it's not mandatory to define. So you can just hit enter. Oh sorry, it's mandatory. I thought it's not mandatory, sorry for that. Okay, we define some port equal to 80. Okay, now service is exposed, and now you can check for the kubectl get services. Okay, oh sorry. Okay, so here you can see now this nginx service has been created. Okay, and here port you can see this one. Okay, 80 3543, all these things. And now for getting the URL, what you can do, minikube service, and the whatever the name is there, nginx is there, and hyphen hyphen URL, it will give you the URL, and then you can access these things. So here you can see the port number which we are getting is 3543. Okay, so it basically what is happening, just a redirecting. Okay, so let's see where we go. Okay, here you have to just enter the URL, and here you can see the welcome to nginx is the web page, the default web page we are getting. Okay, so now just we will revert back to the things, like we will just remove the services, and then we will try to access the web pages. Let then see whether we are able to access it or not, that nginx web page. So to delete, the command is kubectl delete, and the resource, and that is services, and then the name is nginx. So here you can see nginx is deleted. Again we will come upon here, let me reload it. So still we are able to access. Okay, so let me just again check. Okay, it is deleted. Now we will just delete the deployment. So how we can do it? Deployment. Okay, so deployment is also deleted. Now let's check. Okay, here you can see now we are not able to connect to that particular IP. So in this way you can use the multiple kubectl commands. Okay, we have so many, like here you can see kubectl logs and kubectl delete. We did delete right now. Let's check for the logs, what it shows. Okay, log is there, I mean, did you mean logs? Okay, so here you can see expected, what it's saying. If we do hyphen h, okay, we are doing something wrong, I guess. Okay, kubectl hyphen hyphen all.
all containers logs in the pods. Okay, if we do control C and we do this one, so here you can see, uh, okay, okay, let's see some of them, like what we have here, hyphen C. Okay, so let's check the pods what we have. Okay, okay, we have deleted the all the deployment. That's why we are not able to get the pods details. Okay, okay, got it. Okay, that's why we were not able to just get this output of that, and we were getting the error. Okay, so that's all for today's class, and I hope you liked it. If you have any query, you can ask us in the comment section. Thank you for watching, and I'll meet you in the next class. Thank you. Hi, and now in this class we will see how we can deploy a containerized application using the YML file. So in our previous class we have done using the kubectl command and using the kubectl create deployment name. Using this thing we have done it. So now today we will see how we can do it using this YML file. So here is the basic structure of the YML file which we have here. You can just copy it, okay, or you can write the exact same which I have written here. So we will first discuss about this thing, like what is this API version kind, all the we will go in the detail, like I have already written all those things about all the specifications or the detail of each line here. So let's start with the first line here which we have is the API version. So here you can see the API version. So it simply defines the what version of kubectl you want to use. Like if you will do the kubectl version command, then you will get the version of client and server. So there you will get some one dot something something. Okay, so therefore we are using version 1 here. Okay, and simply the kind simply means like what type of deployment you want to do. Means sometimes we create some service, so here we are just defining what we are going to do. So here we are defining like we are going to do a deployment, so here that's why we are using here deployment. And the metadata, and inside metadata we have this name, so we need to just provide the name of the deployment. We can give it anything like nginx or something like whatever you want. And then we define some specifications, like in that we have some replicas. So by default when you do it with the kubectl command, that time what happens, only by default one replica is created. But with the deployment file you can give any number, or like it's all upon you how much replicas you want. So this is about the specification, and here is all the details about the whatever the fields which we have. So here you can see about the selector. So what does it, this field specifies how to select the pods, like how the pods will be selected by the node, all those things. And the template is here we have, so they define the pod template and their metadata, and again a specification of the pod. So basically like what container will be used. So by default what happens, like from the docker hub we choose the image, so we need to provide some information of that as well, like which image should be chosen. So here you can see like in the container we have the name should be nginx, and the image which we are using is nginx, and the latest, what is the latest here? So latest is nothing but the latest tag which is used while when you fetch some image from the docker hub. So there you will see like whether that image is which version of image is it. So if you will use latest tag, then by default what happens, like you get the latest image. So this is the overall like description of this YML file. So I have already created in my machine. So here I will come upon here and just enter the password in this Ubuntu machine, and you can just hit Control Alt T to increase the to open up the terminal. And here I hope it's visible to you. What I can do, I will just show you the nginx, that file which I have. So here you can see it's the same as which I showed you there. So it's same. You can just write as it is. Okay, so now we will see what is the command basically we use to just create the deployment with the YML file. So here you will see like we have this command kubectl create -f, and after -f we will provide the path of the YML file. So currently here, if you will see, so I am in the like this in this directory, like it's the home directory you can say, and here I have this file. Okay, so what I can do, I can just enter kubectl create -f nginx and hit enter, and you will see here we have got the output as that this deployment has been created. To check, what you can do, you can just enter the command kubectl get deployments, and sorry, there is some mistake in the spelling, deployments. Okay, fine. So here you can see the deployment we have, and red is 2 by 3, and let me check again. So okay, here you can see all the deployments are ready. So in this way you can just create the deployment using the YML file. Okay, now let me just start this service. Okay, so how we start the service, this is simple. So it's basically using this expose. So how we will do it, using kubectl expose, and then we will just provide the name or like the whatever is this kind is the deployment, and the whatever the name is here we have nginx ng, let me check again the deployment. Okay, here we have, let me just copy it. You can do just copy using control shift C and control shift V to paste, and then you need to provide the type is hyphen hyphen type equal to node port. This thing we have discussed in our previous class. Okay, if you're not watched, you can watch it. And we define the port equal to 80. So here the thing is basically why we use this expose. The reason behind this is like by default whatever the pod is there, that is only accessible by its internal IP address. Okay, that within the cluster. So when we want to use outside of that cluster, like in our web browser, so for that we just use this expose, and we define then ports and all. So let's hit enter, and the service is created. You can just check using kubectl get services, and here we have the nginx deployment. Okay, and internal IP and external IP is none. To get the external IP, what we do, so we do just a mini cube service and the nginx deployment, and you just need to pass the hyphen hyphen URL. And here we have got the URL. You can just copy this and you can just paste it here. So here you can see welcome to nginx, and it's working perfectly fine. And we can check for the pods kubectl get pods. So here you can see we have 3 pods running. And why 3 pods running? Because in the replicas we had defined that there should be 3 replicas. So that's why there is 3 pods are running. So to check the logs, so what we can do, kubectl logs and the name of the pod which you want. So here is the log of all those things. Okay. So that's all for today's video, and I hope you got it how you can just create the deployment using the YML file. So that's it for today, and now we will stop here, and I'll meet you in the next class. Thank you for watching. Hi, and now in this class we're going to see about the Minikube dashboard. So before starting the class, make sure your Minikube should be in the running status. So let me check. So you can check the status by using the Minikube status, and here you can see everything is running perfectly fine. So now let's start some basic thing about the what Minikube dashboard. As you can see, the name suggests that dashboard. What does it simply means? It simply means one, so there will be a UI, you can manage some kind of things. So it's also the same thing, like Minikube dashboard is nothing but the web-based UI interface which is used to manage the Kubernetes cluster. Okay, so now the thing is how you will use it. So for that we have the command that is Minikube dashboard, and when you will hit enter, and automatically the whatever the default browser which you have, so in our case here we have Firefox, so this Firefox will open and you will come upon on the screen.
So here you can see in the dashboard we have so many things, like in our last class we have deployed one pod, or one deployment was there, and we had three replicas of that okay, that containerized application. So here you can see pods are there, replica set is one, and one deployment is running. So this is the workload status and the deployment. You can see the nginx deployment which we had done, and the three pods you can see here, replica sets you can see. So here you will basically get all the information and whatever thing which we have, and you can easily manage the cluster here as well. So here we have different sections, like here we have deployment section. So here you will see the deployment that we have, that is nginx deployment. And here you can see the age is a day ago, so it means we had done it yesterday. So this is the thing. And now which you will see about the node information. If you need, you will need to search for nodes. So nodes is there somewhere here only. Let me check. Wait, let me go on the home page. Okay, here you can see the cluster. In cluster we have nodes, so we have that minikube as it's a single node. Okay, so that's why we have this so many labels and all. Minikube is the node here. Okay, so in this way you can get so many informations. Like here you will see about the CPU information, memory information, ports you have. So 12 ports we can, and all those things. So moving forward, if you will see about the pods, so if you will come upon here, like here you can see a service as well. So ingress we have not discussed, so will not cover right now. So here you can see the services which you had done, that is nginx deployment. So this is we have. And also if you want to create one or deploy one, would want to do one deployment, so how you can do it, you have to just click on this create button, and here you can do using the yml file, or you will need to write the yml whole thing here. And if you want to do with the file, you can just upload the file. If you want to do with form, you can do with form as well. Here if I write the form as engine what's that, nginx, okay, and the container image we have nginx. And here if I do -2 and just deploy, so you will see one deployment is pending, and it will take some time, and it will, yeah, here you can see now we have 4 pods, 2 running deployments are there, and 2 replica sets. If you come here below in the pod section, here you will see all the details. Okay, so this one is the one pod which just created. So because tag is not here, like in our previous class we had used tagged nginx and letters, so that's why it's like that. So this is all about this today's class. I hope you got to know about something like this, like minikube dashboard. So that's it for today, and I'll meet you in the next class. Thank you for watching. Hi, and now in this class we will see how we can manage the pods. So as in our previous classes we have shown, like when we were deploying some application or some containerized application, so at that time pods were also created, like we were defining how many replicas are needed, all those things like in the deployment.yml file. So now what we are going to do today, we will basically manage all the pods, how we can do it, and we will see what are the commands which we can use. So let's start. Make sure your minikube should be in the running stage. So let me just check the status, minikube status. By using this command you can check the status of minikubes, and here you can say it's perfectly running fine. Okay, so the first thing which we will do right now is we will just create one new pod. So there are two ways. One is using the command line, and other way is using the yml file. So the very first and simple method is using the command line. So how we can do it, just use kubectl run command, and then you need to give the pod name. So here I will give the pod name as nginx-3, and then the image which you will need to provide is this nginx, and it will create one pod. So in this way you can create the pod. And also the other way which we have to create the pod is uh, using yml file. But before that, let's check how how many pods are there we have. So to check that, we have one separate command, that is kubectl get pods. So with this you can check how many pods we have. So here you can see the pod name which we defined just now is, that is nginx 3, and here you can see it's in running stage. Okay, So with this you can check the how many pods we have. These three pods are from the previous classes, and these two also. Okay, this nginx 2 is also from the previous class, and this one just right now which we created. Okay, cool. So now the next thing which we'll do here is how we can just create the YML file, and using that how you can create one pod. So it just similar to the previous class which we had done with the deployment with the YML file. So what you can do, you can just create one pod spec.yml. Okay, and inside that you will need to write the YML code. So how you can do it, it's very simple. The first thing which you need to define is the API version. So you can do like this: API version colon and just give one space and version 1. This one is done, and you need to define the kind. It means what type of object is that, whether it's a pod or it's a deployment. So here you can just write the pod. Next we have some metadata, like we will define the name of the, what do we say, we define the name of the pod. So the name we can define as the nginx task 4. Moving forward, we need to define the specifications of the pod, like containers specifications. So there will be containers, and inside containers we can have the name of the container. The name I will give the here as nginx dash 4. Okay, this is the container name. And next we have image. So the image, what we will do, image we will be using this one same, like this. Okay, nginx is the image. Next we have to provide the ports. Okay, so for ports also the same we have. You can do define the port like this, container port, and the port will be 80. Okay, so now it's done. Like, now what the thing is, here you are defining one container. Okay, and it's one. Again, if you want to define some other containers, you can just copy this thing and you can paste it here. Okay, like this is just array. Okay, so here you can just write some other images and all. Okay, so in this way you can just define multiple containers in a single pod. Okay, so now I just save this file, and what I do, let me just reduce its size. Let me just close it. Okay, fine. So now what the thing is, how you will create with the YML files. So the command for it is kubectl create -f and the name of the file, that is podspec.yml, and here you can see nginx 4 is created. Now when I do the kubectl get pods, so here you will see we have nginx 4. Okay, so in this way you can just create the pods, okay, using the command line or using the YML file. So it's that simple. So now if you want to check the log of some pod, so how you can do it, you have to just use kubectl logs and the name of the pod which you want to check. So I want to check nginx dash 4, and okay, we have written some spelling mistake. Okay, fine. Okay, so here you can see this is the whole log of that particular uh, pod. Okay, nginx 4, in that we have used nginx as the, what we say, here you can see uh, application or image is the right thing. Okay, so we have used nginx image in that container. Okay, so in this way we can get the logs as well. And suppose if you want to do like update in pod, so how you can do it, you have to just use the kubectl apply -f and the whatever the specification file is there, you update there and it will be updated automatically. Okay, and next also very important thing we have is the describe. So how we can do it, to describe any pod, it will give you more information. So kubectl describe pod, and the pod name what we have is pod name, let's take nginx dash 4, And here you will get the all the information like what's the name, namespace, priority, service count, and the node which you have is the mini queue, when it is created, what's the IP in the cluster, everything, and the container ID even, and the image, what is image has been used, image ID, port. So everything you will get when you describe it. Okay. And also here you can see the events, what are the events, the default scheduler here used to manage the pod. Okay, and the pulling, pulled, created, started, these all thing has been done by the help of kubelet. Okay, so now you can just relate to the concept of the architecture, whatever the thing was there in the worker nodes, what were the kubelet was there, why it was there, and also the scheduler which we had discussed. So different types of schedulers. So now you can relate it with all those concepts. Okay, so in this way you can just describe any pod. And also the last part which is here to cover is that is scaling of pod, how you can scale a pod. Suppose if you check for the deployment, let me check, let me just clear the screen. And the command which you have is kubectl get get deployment. Okay, so here you can see we have nginx deployment, and we have this one nginx 2 we have. So currently we have one pod. Okay, and in this we have three pods. So to scale, what you can do to scale, you have to just use kubectl scale, and deployment you have to write, because you're like doing in the deployment, that's why. And the deployment name which we have is I will do in this one deployment. And then you have to provide the replicas. So in the replicas, what the happens in that, when you will provide it suppose 2, so what it will do, it will delete one pod in that. If you provide 4, so it will create one pod. Okay, so it will create on the same configuration which is already there, like in which that other pods are running with that configuration. So same configuration will be used by the next pod as well. So how you can do it, if I do it 4 here and hit enter, and here you can see deployment scale. Now if I do get deployment, so here you can see up to date is 4, available 4. Again let me check, so here you can see 4 is there, means 4 pods are there now running inside that deployment. So if you do get pods, so here you can see we have 1 2 3 4 pods we have. So in this way you can manage your pods. And also the last one which you have is how you can delete the pod. So to delete the pod, the simple command which we have is kubectl delete, and the pod, the keyword, and the pod name, which what is the pod name, I want to do nginx dash 3. So here you can see pod is deleted. So that's all about the managing of pods. I hope you liked it, and if you have any query you can ask in the comment section. So thank you for watching, and I'll meet you in the next class. Thank you. Hi, and now in this class we will see about the Kubernetes services. So basically we will start with the what is the Kubernetes services and why we need it, and some of the types of the Kubernetes services which we have. So we will see all those information in this particular class. So let's start with the Kubernetes services and why we need it. So basically you may have like not may, like you have heard about the pods. What is pods and how it is created and how it is replicated, how it is deleted. Everything we have covered this. So whenever you create a pod, whenever you run a application or a containerized application in a pod, so that time what happens, like sometimes you see like some pods may get deleted. Okay, some pods may be created, some replication is there. So at that time, whenever something happens, some if suppose some new pod is creating, then at that time a new IP is generated. Okay, and suppose one pod is deleted, then that pod is deleted, and at that place one new pod is replaced. Like that pod is replaced with the new one. Then that time also a new pod or new IP address is created. Okay, so to running the application, like all those things, like it will be very tedious to manage all these things. Okay, so that's why Kubernetes services came in role. It what happens whenever you create a service, so it assigns a unique or separate IP address to that, and everyone will communicate with that IP address. Okay, using that IP address, they can communicate easily between them. Okay, so here you can see the definition which we have. Like in Kubernetes, the service in an abstraction layer. Why abstraction layer? Because like whenever an external user will come and request, so he will not be able to see how pods are running and what are the applications are running in that pods and how things are going on. So that's why it's like a abstraction layer, like hidden part. Okay, if you have heard about the oops concept, then you can relate it to that, like the whatever the working should be the hidden. That's why it's the abstraction layer we have here. Okay, so now moving forward, here you can see like it provides a stable network endpoint for accessing the applications and ensuring that they can reliably discover and communicate with each other. So all these things which I just discussed now. And the important thing which we have here is labels and selector. What is labels and selector? So these are nothing but these are used to identify the pods. Okay, whenever we get the request from the external or any application or within the cluster, so that time it is important to identify for which pod that request is coming for. So that time we use the label and selector. So we assign label to each pod. Okay, so as you can see, we have assigned app a to all these pods, and we have selected as a. So suppose if request come for a, then it will redirect to any of these pods. Okay, if we are using load balancer, then it can redirect to any of these pods. Okay, so this is the concept of labels and selectors. Now moving forward, which we have is the Kubernetes types, like not types, Kubernetes services types. Okay, so the first service which we have is cluster IP. What is this? So it is just nothing but it is the default one. Whenever we create a service, then the default IP is assigned to each node. And okay, so here you can see what is the definition which we have. Like it's a default type in service. It exposes the service on a cluster internal. So basically, it provide us the internal IP address. Okay. So here you can see that is only reachable within the cluster, and it enables communication between different pods within the same cluster. So whenever like it is created, like for each pod, a new IP address is assigned. Okay, so here you can see an example. If we have like an example could be a database service that should only be accessed by other services within the cluster. Okay, so this is about the cluster IP. Moving forward, which we have is a node port. So what is node port? Node port is very important, very important. So node port service, what happens in this case, like currently which you saw above the cluster IP, with that what is happening, we are just able to access the application or ports can only within the cluster, not outside that. So to access the application outside the cluster, what we need is the node port service. So with this you can simply access the application from your browser. Okay, so here how things are working, suppose this is the in a cluster we have some nodes, and it assigns the some ports to that particular all the nodes. Okay, and based on that labels and selector, whenever the traffic comes to that port, that node, so it can just based on the nodes sorry, based on labels and selector, it just redirects the traffic to that particular application. So here you can see read all these things about. And also one more important thing here we have, that is for the nodes for the ports which we have, that only port which can be assigned is between the 30,000 to 32,767. That is the range in which only the ports can be assigned. Okay, so this was about the node port. And the next one which we have, that is the basic one, that is the load balancer, which everyone is aware of. Maybe like load balancer is nothing but it is basically used to manage the load. Suppose there are so many traffic, suppose so many traffic, like usually you have 1000 traffic. Okay, but suddenly it increases to 1500. So at that time what will happen, at that time it will just redirect the load to different applications. Okay, like suppose pod 1 is handling 500 users, this one is handling 500, this one is handling 500 users. Okay, or this one is handling 200 and this one is 100 handling 600. Then in that case, this is on this server or on this pod there is low load. Okay, so then what happened, the load balance will just transfer that load to this particular pod. Okay, you can just read this definition what we have here, like this service type assigns an external IP address to the service. It distributes the incoming traffic across multiple nodes. Okay, that the thing which we have covered. Like here you can see, for instance, if you have a web application, a load balancer service can distribute the incoming web request across multiple pods running the application. So with that load balancer, we will have the feature of scalability and redundancy. And last one which we have is external name. It's nothing but the alias name. Okay, suppose some service is there, and which you don't want to expose it to the externally, so at that time you can use external name. Like it will just suppose you want to use www.google.com, and you can just assign it to the assign to as my search engine. Okay, so this is the concept of external service. You can read this type of service used to provide an alias or redirect to an external service outside of the cluster. It allows you to use Kubernetes service to refer to an external service by its DNS name. Okay, so example, you can see you can create an external service called this, and that points to this. Okay, so it's just like allies. Okay, so that's all for today, and I hope you understood it. If you have any query, you can ask us below in the comment section. So that's it for today, and I'll meet you in the next video. Thank you for watching. Hi, and now in this class we will see about the implementation of Kubernetes services. So we had already discussed about the cluster IP, load balancer, node port, and external name services. Okay, so currently in this class we will see the implementation, how you can do with the commands. So before starting the video, let me just check the status of the minikube. So it might be running. Okay, so it's running. So you can also check in your case by typing this command, that is minikube status. Okay, moving forward, what we have to do, first of all, we will create one deployment. We will do one deployment. So how you can do deployment using kubectl? So we will do kubectl create deployment, and the deployment name I give today web app, and the image that I will use is nginx. So okay, I forgot to write this hyphen. Okay, okay, image is created. Now we can just check the deployment using get deployment command, and also we will check the pods. So where you can say web app pod is has been created, like one is running, so only one pod has been created for that single deployment. Okay, so now moving forward, what we have to do today is I will first show you one picture. So here you can see that I have these four service types and what services we can expose to the outside world. So as you know, cluster IP we cannot, node port yes we can do, and load balancer we can do, external name also we can't do. Okay, so let's see how we have to do. So the first thing which we do is that is cluster IP. So as you know about the cluster IP, it's created by the default. Okay, so now first of all we will check what are the services we have already. So kubectl get services, if I do, so you can see I have only these two services. Now what I am going to do, I will just create one what type of service we can say, cluster IP service if I do. So how you can do it, but we cannot expose it to the outside world. So to expose that cluster IP service, the command which we have, that is kubectl expose deployment, and the name of deployment we need to use, that is in our case we have web app, and then here we will not define the port. Sorry, port I'm saying. Here we will not define that type, what type of service we want to expose. So if you will not define it, so by default it's cluster IP. Okay, so if I do it, so let's check again the get services. So here you can see the type which we have, that is cluster IP. Okay, so this is the cluster IP, the type which has been created. Okay, that service. Now in the cluster, like if there are some other ports as well, then they can communicate to using this IP. Okay, so now moving forward, we have that is node port. Okay, so what we can do with that? Okay, and how we will do it? So let me just clear the screen, and again I will be using the same command, but here instead of uh, like we will add one more flag, that is hyphen type, and here we need to define the type is node port. Okay, so here the type will be node port, and if I will do hit enter, then what that service will be created. Okay, so here let me tell you something, like here the port which you are seeing here, that is port equal to 80, it means like you are like that your application, whatever the application is running, that is running on that port number, that is like here in our case that is nginx. So nginx basically runs on port 80, so that's why we are defining here that our application is basically running on port 80 in the pods or the container. Okay, and here we are defining the node port service. So what will happen for the node port, we get the ports assigned between 30,000 to 30,000 32,667. Okay, so between these two that port will be assigned. So if I do hit enter, So here you can see web app already exists. Okay, no problem. So what we can do here, I will just use dash and I will write a node port. Okay, so okay, sorry. Expose deployment web app. Okay, yeah, I forgot one thing. See, we need to provide that hyphen hyphen name equal to web app hyphen node port. And here you can see service exposed. And if I do get services, so here you will see web app node port. Okay, so here you can see that type is node port and the name of this service is this web app node port. So now what we can do here, now we can just check the what URL has been assigned to that. Like, because of node port service we can access this outside the world. It means we can access it using our browsers. What are the URLs, how you will check the URL, and what is the IP address, all these things, how you will check it. So here you can see the first which we have, that is port number, is this one we they have assigned, that is 32,000 to 49. Okay, so now what we can do, actually this is we are doing in minikube. So in minikube we can check the IP address using this minikube IP. So this is our IP. Okay, so using this IP only we can access that particular service. So what we will happen, what we can do, we can just copy this, and let me open up this Mozilla Firefox, and I will just hit enter, and I will paste the 322249 was that, I guess. Yeah, so here you can see that default web page of Nginx is coming on the screen. So in this way you can access the whatever service you want using this particular IP. Suppose, and now suppose if you are in the like working environment, or there are no only one node and one master node and one worker node. So what you will do in this case, so in this case you can use this command, that is minikube service, and the name what we have is here web app, service name is web app node port hyphen hyphen URL. Okay, so this will give you the URL. So this is the same URL which we have used just now. Okay, so in this way you can use the node port service as well. So that was very easy actually. So, and let me tell you some story behind it. What actually happens when you create this service. So suppose in your cluster you have 2 to 3 nodes, like worker nodes. Okay, so at every node, what will happen, at every node that port will open, that current port which you are seeing here, that is 32,249. So what will happen at every node, that port will open, and then whenever someone request, so whenever someone requests to that particular your service, so it will be redirected to the Kubernetes service, and then Kubernetes service will decide to which pod or to which like whatever service they have to provide. Okay, this is the like some stories. So actually node port is also considered as like not secured. Okay, because it opens the port, and suppose some malicious user come, then they can access that port, and some information can be like what we say, the word that is ransomware or something like that. Okay, so now moving forward, what we have to do here is we will talk about now, that is load balancer. Okay, so we have already discussed about the load balancer. So how you can expose that load balancer service. So this is the same thing which we do. We have to just sorry, we have to just change the name here. That name which we have, that is load balancer, and the type which we have is and the type which we have is load balancer. Load balancer service exposed. Let me check the services. So here you can see web app load balancer is the service created, and the here you can say it's pending, because we it's not like load balancer is not here, like we are just doing it all these things locally, that's why it's showing external IP as none and pending. Okay, so moving forward, what we can do, let me just again check the IP of my minikube. What it is? Okay, this one, and here you can see the port number which is now assigned is this one, 30,317. So if I will do this, change the port number, then also what we can do, it will just come on the screen as well. Why this? Because like
we are accessing this on this particular port, but our whatever the thing is, it is redirecting to that particular pod which is running this service. So that's why it's happening because of Kubernetes service. Like it is all being managed by that service. Okay. So now the last one which we had, that is external name. So let's see how we can do it. So what we can do here, so for the external name, what we do basically, we cannot directly like do here because we are doing in this what we say in Minikube. So as it's locally, we cannot do, and we cannot expose to that outside world as well. So I have a file which I have created already. So here you will see if test.yml. So here you can see how you can just create that particular service to that external name, exposed to that external name. So here you can see in the place of name, you can write that whatever name you want. Okay, like whatever the name. So whatever the name of service is here, okay, and in the external name, you can define the whatever the external name or external some domain name is there. Okay, you can write like that. Okay, so then internally it will work. Okay, so to implement that, you can just use this command. Okay, so in this way that external name service will also be exposed. So that's all for today's, and I hope you like this, and if you have any queries, you can ask us in the comment section. So thank you for watching, and I'll meet you in the next video. Thank you.